All right. So what we're going to do is we're going to start looking into some small topics. So today we're going to cover a few topics, and then later today and tomorrow we'll start using them in the tools. Now, as a quality assurance person, nobody's expecting to write a lot of code. But as you get into some of the automation and some of the tools, you want to be comfortable looking at the code and understand what it's trying to do with from the scripting point of view. So let's talk about very basics programming concepts. Mostly, if you've done a lot of math, this thing is going to be a lot more similar. You're going to see it. It's essentially, you take a look at the code snippet and then do it. So when you look at most of the programming language, okay, all of the program structure has similar construct. Okay, so you start with something as a so always you will have something like a start of a programming block. Okay, then we'll have what we call it some variables declarations. Then you will have some executable statements. And then you will have end of block. This is going to be more or less kind of structure you're going to see it. Some, depending on the language, you always will have an ability to name the block. And depending on language, some may call it a function or procedure or class structure. Okay, so let's take a look at a sample program. Okay, so there are two different languages. The top one is a Transact SQL, which is the language typically used in manipulating the data from a database. And the bottom is a language which a lot of times known as the 4GL languages, which is a 4th generation language. Essentially, Java and the C#, you will hear a lot of commonality when you get into industry that, hey, what is the platform? Is it Java? Is it C#, .NET? So this is the language for that. So this code snippet does nothing but just a simple print on the screen called hello world. Okay, so if you look at it at the top, right, you have something known as the program declaration or block declaration, right? It says, hey, I want to create a procedure, and the name of the procedure is hello world. And I'm then just creating a block. Remember, we said start of the block, end of the block, right? So start of the block, end of the block, begin, end. Inside it, you will have some variables. But in this case, all I'm just doing is simple print. So I don't need any temporary storage, right? So variables are nothing but a temporary storage. If you use calculator, right, you try to do it like 2 + 2, and then you just click on store into the memory so that you can recall it at a later stage. Same thing, the concept is the variables. And then there is an executable statement. So this particular statement is an executable statement. Okay. Same outcome if I want to do it in a Java language, right? This one is called a class, which is a constructor more on the a block declaration. Inside that, they call something as a main, right? Which is nothing but a starting point in a any Java program. And then they have used curly braces essentially as they start and end of blocks. Okay. And then this is your executable statement, which matches to the print hello world. Okay. So you can clearly look at it and says, hey, when it's going to start running the program, it's everything which is on the block is what it's going to get executed. Okay. Here's another example. Okay. This example uses also the variables. So if you look at it, right, this block is exactly same declaration, right? So I'm naming this block as my example. I'm creating it as a procedure. Then I'm calling variables, temporary storage. And then I'm saying it's going to have a multiple execution statements. So I'm going to build it in the block. Right? Same as like the previous one with hello world. But in this case, the first statement allows me to set the value of the variable. Right? So I'm setting my age as 21. Second one does it in middle initial. Now notice it, one is age is type of a number, right? So you're calling an integer. And the middle initial is always a character, right? So you're saying it's, hey, it's a single character. Okay. And then I'm using the print statement using that what is my age and what is my middle initial. Okay. Any questions on the top block? You understand it, how it flows. Okay. Exact same thing. Here are the variables. Integer, and in case of Java, you define it as a string, right? It's a character, it's nothing but a string which contains only one character. Performing the same thing, setting the age, setting the middle initial, and printing them. Okay. Exact same block. Now, some of the things that as you go into programming language, right, you need to have some sort of operations. So like it's whenever you do math, right, you have operators. And then you perform a whole bunch of things. Right? So in the language, computer programming language also, you're going to see it's something known as a Boolean Operators. Right? And it evaluates either as a true or a false. Right? So think about any condition. Is this a true or false? Remember when we said, does it meet 3C and a T, right? And expected answer is either yes or no, right? It's whether it's true or it's false, right? So if you're using a plain math, right? There are 3 Boolean operators, right? And, or, and not. And this is how would you represent if you're writing an equation, mathematical equation, right? Upper caret, lower caret, and then the tilde sign. In SQL, you will use explicit word and, or not. Same thing you will use in the Visual Basic. Versus if you look into the 4GL programming language, you will see something as and as an ampersand, or as a 2 vertical pipes, and then exclamation point is going to be the null or the false condition. And then you will have a comparison operator, right? So you're going to check for certain conditions, right? Where things are equal, right? Remember, when you do an expected results, you're going to compare them. Is the same? Is it different? And if it's different, is it greater than or less than equal to? So you can see it, the mathematical operator, and how those translates into the programming language. It's going to be fairly similar. And then you're going to have similar assignment operators, which you just saw it when you were assigning the value of the variables. Okay. And the third key aspects that you need to know it when you're looking at any programming block is the conditional statement. Okay. So whenever you look at the block of code, right, it's going to have one of the three flow, and what we call it is a aspects of how the statements will get executed, right? The first one is sequential. So when we looked at the here, right, this 4 statements which are part of the block, they are sequential. So in other words, this will get executed first, then this will get executed, this, so it's an order in which the statements will execute it. This is a sequential statement. Okay. In addition to that, you're going to have conditional. So depending on a condition, you're going to make a decision. You're going to do it one or the other statement execution. Okay. And then you're going to have an iterative where you're going to repeat certain things for a certain amount of times. Okay. So here is the sequential and conditional combined when you can see it. So what's it? What is that statement? It's a variable declaration, right? It starts the begin and end, right? The block. Then the first statement it will execute is department equal to 5. So this will get executed first. Okay. Then I'm going to follow up sequentially to the next statement, which is a conditional statement. Right. So it's going to validate and says, hey, if department equal to 5, right? That's an equality operator. I'm checking it. In this case, it is 5. Right. So then I'm going to do it this print statement. Okay. This else, it's not going to, right? Because the first condition is true. This was not true. So it's going to ignore this 2 statements and then go to the end. Right. So even though I have a piece of code, based on a condition, only some part of the code will get executed. Right. So if I would have set my department value, let's say it's 6, then I check this one, this will not get executed. The else component will get executed as the next statement. Right. So that's a condition. You can check it and say, hey, if the certain things are true, we'll do it. So think about, right? So the examples that you just said, right? If the state is provided into the dealer creation, then you're good. If it's not provided, you want to push them to reprompt it again to enter the state information, right? So those are the places where you can start using those conditional statements. Okay, is this true? If so, I will do this statement, else I'll prompt them this thing. Okay. The bottom one, it's exact same piece of code happening in C++. Any questions on this one? Just understand how the conditional statement works. All right, then there is an iterative statement. So there are scenarios where you have to do certain things repeatedly for a certain amount of time. Right. So I want to keep repeating it, asking user a prompt till they enter a valid number in the load calculator. Right. So I want to do that. So it will be a repeated statement. So there are 2 ways you can do those kind of things. One is for loop, and the other one is a while loop. Now, for loop is essentially predictive. It clearly tells you how many times it's going to get executed. Okay, versus while loop, it's going to check on certain condition and it's going to execute it till that condition is true or met. Right, so it's an unpredictable, but they both more or less can do exactly the same thing. So here's an example of for loop. Okay, I want to do it, print the hello world 10 times. Okay, so I will start with my initial value as 1. I'll keep doing that till I becomes less than or equal to 10. Okay, and then I'll do I plus 1. That means every time I go around the loop, I'm going to increment I by 1, right? And then I'm going to print it. Now, a lot of times when you see certain things does not happen properly as a quality assurance person, you look into this kind of conditions. See if it's I is less than equal to 10. Sometimes programmer just in a hurry just says I is less than 10. What's going to happen? It's going to happen only 9 times, not 10 times. Right? So if you see those kind of behavior, you know, hey, where to look for it or what to advise them. Okay. And the right hand side, it's exact same piece of code, but it's done in a while statement. Okay. It's going to keep doing it till I less than 10. It's going to keep printing it, and it starts with 1. Now, what happens if I don't add this line in my code? It'll keep printing forever, right? Because it'll always be less than 10. There is no increment in I. So this is where like it goes into incrementally. Okay. Any questions on this? Okay. So that's.
There is always a condition if there is a while, right? While.
Yeah, this is always this condition, right? And this one essentially is always a Boolean, right? It has to come out either it's true or false, right? So in this case, when I is 1, is 1 is less than or equal to 10? No. Yes? Is to say no. Is 1 less than a 10? It is true, right? 1 is less than or equal to 10. Then it's going to go. Next iteration, it'll become 2 less than equal to 10. Yes, it'll go. 3 till it hits 10. Is 10 less than or equal to 10? Yes. It'll still print 1. Then becomes 11. I'm going to go ahead and say, is 11 less than or 10? No. So it's going to break out of the loop and continue the next stage. Okay. So that's called tracing. You go through it. Right? All you did it is static testing. We didn't execute any code, right? We just went through it and says, is this going to do what it's supposed to do? Okay. Any questions before we jump into the next topic? Second thing you're going to encounter as a quality assurance person is HTML. Okay. So what is an HTML? It's a hypertext markup language, right? What is it used for? But right, it's used by browsers to interpret and display the content. Right? So let's look at first how things works in the world. Okay. So when you go to any website, how does things happen behind the scene? Okay. So you have a browser, right? Well, let's say you get CNN.com. the moment you type it, what happens behind the scene? Right? It goes to an internet cloud, right? Goes somewhere, finds the CNN.com for you, ranks it, and puts it into your browser to display. What happens is behind the scene, it takes that address and maps to a physical machine. So there are domain controllers, which along the path on the internet, it essentially looks up that request and says, oh, CNN.com, it's mapped to this server. So let me send that to the server. Okay, those servers, when you look at it, are nothing but a physical machine. Okay, I'm going a little bit technical, you don't have to worry about it, but all machines have a unique address known as IP address and a MAC address. Okay, so that's how everything gets identified in the digital world. It always has a unique name called a MAC address. And while it's up and running on the internet, it will always have a unique IP address, which is an internet protocol address. Okay. Initially, it used to be what we call as IP4. Essentially, it's a combination of 4 groups of 2 characters. Now that's an IPv6, so it's a combination of 6 characters of 2. Okay, and then
Can you give an example of the IP?
okay, so you will see something like 10.8.20.251, right? This is IP4, right? So there is 4 groups of numbers, which will range from 0 to 255 each. Okay. So essentially, each character, and digitally it represents as 2 bytes, and then that's what maps to 0 to 255. Okay. So even when you look into your own phone, right, and you're trying to find, hey, what is the IP address? It'll give you one of those kind of numbers. And then it will also have a unique known as the machine address characters, right? So it will have, I think the latest MAC address is like 6 or 8 tuples, right?
Yeah, 32 or 32, 32.
Yeah. So it'll be a something which will go from 00,
It's a MAC address.
MAC address. Okay. It'll go from a 00 to FF. Okay, so it'll go from 0 to 9, and then A, B, C, D, F. The second character will also go from 0 to 9 in A, B, C, D, F. And then you will have a combination of 6 such characters. So you will see something like this on your MAC address. So you will see it also on your phone when you look at it. So every device, irrespective whether it's a phone or it's your watch or your laptop, or even if you have a Wi-Fi sensor for your temperature control within the house, right? So if you're using a Nest that is like connects Wi-Fi, it will have a MAC address and it will have an IP address when it gets connected. So
That's
every
even unique in the
in the digital world, everywhere you go, those two are the basic building block of how it finds everything.
It's like your home address, right? It's like somebody can send you a mail anywhere in the world and you will get it, right? Same thing in the digital world. You have a unique address.
It'll come to this particular machine, right? So when you do a CNN.com, right, there's a domain controllers which are set in the internet along the path as the things routes, right? They will take that and they will find where is this located. Okay, and it'll ask the network, please route my request to that. So it will get to what is known as a physical server. Okay, that server will be having that IP address. Okay, so typically all those lookup tables that I mentioned that will look at it, it contains what the name is, cnn.com. It'll put what the IP address is, and then it'll also have this IP address is mapped to this many machines. Right? So that goes to a server. Within that server, now you have a concept, something known as a web server. Okay. So web server is nothing, but if this is a physical server, it has a virtual server which runs with certain capabilities. Okay, so you can have one web server running within your own machine laptop. It doesn't require a physical, a separate kind of server grade machines run on your laptops too. Within those web servers, okay, they have something known as web application. Okay. So think of it, a web server may have cnn.com. It may have rflum.com. There are multiple applications that you can host on it. Okay, and each web app is nothing but a group of pages known as web pages. Okay, so these are web pages. Okay,
So are these all things that we're supposed to like know? We need to memorize.
don't have to memorize.
We should have-
I just want you guys to understand how everything works. Right, so remember there is a page flow diagram in the system design document.
Right.
That essentially talks about how all these pages are organized within the application. As you go through it, which page gets loaded what point. Okay. And then out of all these pages, there is only one page, which is a special page known as finally it shows up. A home page. Okay, so whenever you start an application, by default, that page gets loaded. Okay, sometimes it's also known as index.html or home.html. Okay, so when you put a request and when you just simply type cnn.com, it goes to a server based on the IP address where it's mapped, looks within that web server, is there an application called cnn.com? If it finds it, then looks into what are the pages that are index.html page. Yes, then it takes that page, sends it back over the internet for that application to be displayed. Okay, so let me see if I can show you guys one. Okay. So I'll just okay. So when I did this, it goes through it. It went over the HTTPS protocol. It found the page, the home page, and loaded it. Now, then I said, you know what? I want to like just go to US specific news. So the moment I click the US, look what happens at the top up here in the URL window. Okay. It goes, puts a /US, right? So now it went in the same route, but it also has the US. So it says, oh, from this server, from this application, don't just get me a home page. I want a page known as a /US. One of the other page will be /US. It takes that page and then goes back and gives you the display. Okay. So as the page flows within the application, remember how you had within Rflow, you do a login, then shows a home page. And then when you go home page, if I click on loan calculator, it shows me loan calculator page. That's what this thing is doing, right? So every time when you do go into rflow.com, let's try to go there. Or show.
Rclone.w website.
Okay.
Take you seconds. Focus.
Okay. So went to the home page, right? I don't know if this is still active. Okay, so look at this. It's a admin page, right? So as soon as I logged in, it says login. It went and says, what is your login page? Well, I'm logging in as a site administrator. So let me pull the site administrator homepage and give it to you. From there, if I just go to user management, watch, things will change at the top and it change it to the user administration page. Right. So it goes to the application, tells me, give me this page. Okay, that's how all of the information is organized within HTML application. So whenever you're testing any web application, right? And then when you try to click on something, like it goes and gives you a blank page. Look at the URL, right? And then you can tell it to developer when you open the bug. Hey, I try to go to this page. This is the path that I took it to go to that page, and it shows me a blank. And while it's showing the blank, this is the URL it shows at the top. So now they have a better understanding of when it is, and they can look at the URL and figure out the path in the code. What's the problem? Okay. Any questions? Do you guys understand how the web services work?
Yes, I have one question.
Go ahead.
So does the URL tell you the web server name and the application, everything?
So
The URL.
it tells you this is the application, right? So it goes to similar to cnnet.com, right? It says this is the application, web application. So all it does it is azurewebsites.net is the domain name that it looks at. So when it goes to here at the internet, right? It looks for it's give me the azurewebsites.net location. Okay. And the first things before the first dot, the Rflow is the web application. So it tries to goes to the azurewebsites.net and says, okay, on that server, which is a web server, says, do you have an application called Rflow? Yes. Okay, I have that application. Then it just says, what is your home page? Give me home page, and that's what it gets displayed. Does that help?
So yeah, can a web server have multiple web app?
It can have multiple web apps, right? So I can have as many web apps as I wanted. Okay, and within a physical server, I can have multiple web servers.
And this multiple web server will have different IP as well as multiple web app will have different IP.
Now, the different ports, IP is tied at the server level, the physical assets, or sometimes it's a virtual machine. So it is tied to those virtual machines.
We having different ports.
Yeah. So think of this way, right? So you will have a server has one to many servers. Okay. This has IP address. This runs on the same IP address with the different ports. The web servers. The web servers will do that. Okay. So web servers has ports is nothing, but like it's think about it, if you're staying in a apartment building, right? Your building and street address is still the same, but then it has its specific unit number, right? So think about it. My IP address is always going to be the same, but the unit number is port. Okay, so every web server will be binded to some port. Within that, right, it has one or more web applications. Okay, each web application is then it's going to have one or more pages. Okay, that's how it traverses it all the way to get the information for you. Okay, so that's the relationship no matter where you go at what web application you're trying to do. Okay, so when you go in a real world, right, they may have, hey, that is the same test server, but it has 5 applications running on it. And then you are interested in specific one applications to test it.
Somebody had a question here. Eric, was it you?
Yeah, I did, but I was just wondering, so like the page, so on the web pages that already, is it created by the web developer and it's already in the container?
Right, we're gonna walk in a brief moment what that web page is on. Fine. But I wanted to make sure you guys understand the whole how the web page comes into the play. Okay. All right, so we talked about the web server. Website is nothing but an application, right? The web pages is essentially individual pages, and home page is what is the first page gets loaded into the application. Okay, so when you try to build those web pages, right, you just don't blindly decide, hey, I want to build this or I want to build that. There is a design process that you go through it and says, hey, what kind of site I'm trying to build it? Is it an informational or is it a transactional site? Right. So for example, the way you build it and lay out things on a CNN.com is going to be different than Amazon.com, right? Because Amazon is geared towards the retail mindset, versus CNN.com is geared towards the informational mindset, right? So you look at it and says, what type of information you want to put on that site, right? On Amazon, I want to put all the products. On the CNN.com, I want to put probably geographic locations so that I can categorize, or the type of the news, right? Whether it's a sports, health news, or business news, those kind of things. Right, so you build those kind of goals, you organize how you want that information to be organized, and then you build up pages from that organization. Okay, so HTML is essentially a language that's used to create web pages. It's nothing but a hypertext markup language. The intention is the browser is going to read that, not you as a human. Right, so every browser needs it some sort of essentially aspects which tells it how to parse or how to display all that information. Okay. And the way it does it is through something known as a series of tags. Okay. So tags are nothing but a set of characters that are kind of surrounded in the angle brackets. So one example is this one, right? So it has an angular bracket and capital B in it. All it tells the browser that everything that follows that, make it bold. So when you go to some web pages, right, you will see certain part of the page is bold, other part is not. So if I want to bold certain information, I'll say put it into the bold. Okay. And most of the tags will come into what is known as pairs. Okay, so for example, this is the pair for bolding a text. All it says, when your browser is looking through this HTML text, it says as soon as it hits this particular character, it says everything from this point onwards needs to be bolded till it comes across a character which is slash and the exact same character as what was present before, capital B. At that time says, okay, now turn off the bold. So think about that this is an on switch and this is an off switch. Okay. So that's how browser treats everything. It's a sets of on-off commands. Okay. Now some tags will have an exception because it doesn't require on-off. Like for example, get me to the new line. Right? Because there's nothing called on-off, right? New line is, hey, I'm going to leave this, I'm going to start with the new line. Similar to paragraph, okay, I'm going to create a new paragraph. Okay. So that's essentially in a nutshell, the basic structure. The HTML helps it, the browser to understand it. Okay.
So,
Uh-huh.
you see like where it says I.
LI.
You start with I and end with the slash B, or it always has to start with the B and end with the slash.
Hang on. It'll always, the pair always be there, but you can nest them.
What is that?
Okay. So I can have something like it's, hey, I'm going to do a bold. Okay. And then I'm also going to do an italicize. Okay. At some point, I'm going to stop italicizing it. And then I'll stop bold, right? So this is called outer layer, and this one is nested inside it. Okay. Now, what you can't do is you cannot crisscross. So you can't say, hey, I want to do a bold, italicize, and bold, and italicize. Okay, because now you reverse the order. Right. Sometimes it's known as you have to follow what is called as a LIFO, which is last in, first out. Right. So this is the last in was I. You need to pop it out from that first before you can pop out from the bold. Okay. So here's an example, right? Same as the bottom one that I was doing. You can do that, right? Some of the other things you may have to think about is in HTML, you don't have a case sensitivity. So in other words, this is same as this. Okay. Second thing you cannot do it is you cannot create your own tag in HTML. So I can just go and create it. Something known as, okay, I can't just create. There's a lag in it. Okay, so I can do something as my tag in HTML. Right, it's going to give me an error. This is not allowed. Okay. So if you want to know what are the sets of tags, you can always look it up into the HTML syntax. It says what are the eligible or legal tags that I can use it. Now, some tags may have what is known as an attribute associated with them. Right. So let's say if I'm trying to create a new paragraph, but then I want to align it in the center, then I can just say, hey, start a new paragraph. And the attribute is align equal to center. So it's going to align it into the center. So when it gets displayed on the screen, you will get the feeling that the whole page is the paragraph. This particular section is in the middle. It's not left justified, not right justified, but it's a centered align. Okay. Now, you want to be mindful. Remember, I say it's when you do the testing, a web application testing, one of the testing you have to do it is compatibility testing, where we said, hey, if I have a different version of the browsers, whether it works across those or not. That's because not all the browsers supports all of the tags. So there are some standard tags that every browser supports, and then some are advanced tags that the newer browser supports. Like, for example, if you use an Internet Explorer, it may not support certain tags that is kind of supported in Chrome or in Microsoft Edge. Right, that's why they try to phase it out. Hey, this is an old browser, it doesn't support all the tags, so let's just get it out, make sure everybody's new so that everybody gets the latest functionality. Any questions on these things? Before going that, let me talk about that. Okay, so when you think about the structure of an HTML page or a web page, it's always grouped into two different groupings. There will be a section that acts as a header. And then there will be another section that acts as a body. Okay. Everything which is in the header section, it's not going to be visible in the page. Okay. It is all of the instructions, all of the metadata that is associated with the page goes into the header section. Everything that needs to be displayed on the screen goes into the body section. Okay. So let me show you guys one simple example.
Sometimes we open some sites and we can see the codes.
All right, hang on. I'm going to show you guys something. Okay. So this is a simple HTML page. It's good enough. Everybody can read it. Okay. So this is an HTML page or a web page when it gets displayed. Okay. So it has a container, right? Outside container. Oh, I can't use this in the text. All right. So if you can see it, outside tag. So it says entire HTML page is there. Inside it, it has two nested things. Head and title. Right? So title finished first. Head finished second. Once it's done, I'm going to start the body section and displaying everything in the body. And then the body section.
So like, why is there a tag? Like, so you see where it says title on the third one, the third line. Now there's a tag on that one, and then the last two, and then on the other rest of it, it all starts at the beginning. Is there like a reason why? Or
When you say begin, oh, you're talking about, no, this is a white space. Like this? This is a white space. I can do whatever I want.
you bring it back all to the front.
Yeah, if I want to, I can bring it all the way far. It's essentially, you do it based on whether it's readable. If you do it this way, right? Human brain, right? It's harder for me to read and understand where things are, right? Versus if I do it something like this. It's much more easier for a structure to me, hey, how this information nested, right? So if there was a problem, I can say it's which area it's a problem. Right? So let's do this thing. So I'm going to save this thing. Okay. Now I'm going to go ahead and open it, right? I'm going to go say, hey, I'm going to open with a Chrome browser. Okay. Notice a couple of things happen. See what's happening at the top? Up here, right? I don't know why it doesn't work. Okay. So it's a hello world. Watch what we had it on the title. Right. But it's part of the header. right? So it's not displayed within the page, right? So this area is the page, right? This is the configuration or metadata information around the page. So it's what is the page called? It's called a hello world. Okay. Then this is the content, which so you see it's in the body. I had a hello first page. Right? So if I change this, it'll say, and if I just go ahead and save it, and then I go ahead and say, I'm going to refresh this. Notice it. Okay. Now watch this. Okay. I can put it in the new page. Right. It says, hey, what should it do? It's not going to do anything. Because you haven't told a browser that you need a new line. Right. So just because you have read it, the layout here or formatting on the page doesn't matter. It's what the browser can interpret is what matters, right? So if I just simply change this to here, I'm going to put a new line break. Look at that. Moved it. After that, it says there is a line break. So I'm going to start it in the middle. Okay. So that's how the HTML works. Now, if I have to create a new one, then essentially what you do is open any editor. You can have it specialized HTML editor, or you can do it a notepad type of editor. Type it whatever the context you want to do it, right? As long as you follow all these rules, right? There's a header, there is a nested tags, right? You do it a proper nesting. As long as you follow all those rules, you can write whatever you wanted in that page, including you put the images, you can put the forms, and then get displayed. Right? You put all of that into the notepad, right? And when you save it, make sure you save it either as a .htm or .html file. Okay, once you save that, then it'll create an HTML page. Okay. So let's say if I would just say it's a new one, right? So I can just say it's HTML. I just say it's okay. So it's created it on the page, right? I can just go and say it's file save as. Okay. You can go in there. I'll change this to all files. Okay. Notice it. I did the .htm at the end. Okay. And then I just say it's saved. So now it's saved as HTML file. So if you look into this, notice it, my second page, right? So if I click on it, it'll get open up. This one. Remember what I put the title? This is new page. This is bold and italics. So that's how you create an HTML page. It's very simple. Do it, right? If you make a mistake, you will see it, things will show up goofy on your page. That's when you know it's wrong. A couple of things you can also do it. If you right click on it, any browser, there is something called a view page source. If you click on it, it'll show you exactly what your text looks like. Okay, so while you're doing a testing, if a page looks up goofy, you can right click on it and say it's a view page source. And it'll show everything.
You can also hit F12, right?
Yeah, there are shortcuts. You can do that, right? But just keep this in mind, because when we do it, some of the automation testing, this will come in handy because you need to know what are the controls and what they're named as, right? At that point, the view source is much more effective way to do it. Okay. Then if you look at it, right, your HTML pages are not just a simple HTML page, right? A lot of times, like look at the login page, right? It has an ability for you to enter the information, right? And it has the ability to click on submit, right? So it's some sort of an input and some sort of buttons. So there are a whole bunch of what is known as a data entry control available in HTML that you can use. Okay, so you can use it like things like a text box, which essentially gives you an input where you can type in as a text, right? Then you will have a submit type where you can say, hey, remember you have a login. You can name that page and you can say it's that input type is a button and it submits it. Or you can create a radio button or a drop down list or a checkbox. Okay, all of these controls are known as objects. Okay, so when we go and actually do some of the automation, right, the computer has to figure out which object you're doing it. So this is the way that it identifies a unique objects on the page. Okay, so here is the example, right? So okay, so if you look into this, here's how I'm doing its different input type, right? A drop down with a different option value, right? A checkbox and a submit type of things. So if I go ahead and display this, you'll look at like something like this, where I have a drop down and enter the value, select the value. I can do that and I can do a submit. Okay, there's a link to going into different web page and URL. Okay. So that's what this page is. Okay. And like I talked about, right, you can add images. And the tag that you can just use is image, and the source is essentially then identifies where to load the image from. Okay. Sometimes you will see it if you're loading a page and it's taking a time. So instead of image, right, there'll some sort of a box will be drawn and some text put on it. That's known as an alternate text. And in this scenario, it says, hey, while it's taking a time to load it, I want the browser to display my image as the wording is an alternate thing. Okay. And you can do the link through the URL tag. Okay. Why it's an important? Because as you go through it, most of the applications that are web application you're testing, it's going to be built on web pages. Right. So having an understanding of how HTML is formed, enables you to read it and understand what is wrong on the page. Okay. Now, we're not going to do a lot of homework here, but what I would like you guys to do it in the instructions on the PowerPoint slides, there is a step-by-step instruction of how to create an HTML page. It's exactly like what I just showed you while creating a second page, right? So we'll give you a homework towards the end of the day today that you need to write your own HTML page. And then we'll just look over it on Thursday. Okay. Any questions before we move on to the next topic?
If you want to talk about the W3.
Yep, I was going to take it both in that. So Harshal pointed out, let's talk about now instead of talking a little bit later. So if you go to a web page called w3schools.com, just write it down. This is the resource that it's much more useful for you. Okay. And when you look into that, they have a whole bunch of tutorials. Okay. And you can start with learning the HTML. Okay. Nice thing on this side is you can actually write any of the code and test it. Okay. So you can say, hey, I want to try myself. And it essentially opens an editor, right? And on one side, as you do it, it'll display what it is. So you can go ahead and play around it. And then I say it's new, and I want to run. Okay. So it just keeps doing it. Still loading it up. Okay. See it? Started changing it. Keeps doing it. So you can go ahead and figure it out and play whatever you want. Right. So see in that. So write it down, that play around with it. It has a lot of things in it. Okay, you can do it. And we talked about the data control. So all of the drag and drop, you can put the media in it.
Yeah, important part is actually the form.
Forms, right? The forms has all the data controls. Right, so it gives you how you do all of that. Right, so you look at the try yourself. It will show the forms. Right, here's the label. Here's the input thing that we talked about. Right, so I would strongly recommend all of you to spend some time, go to W3 schools, play around, learn with it. Right, there is no point in me manually telling you everything that is nicely laid out into that side. That's part of the reason why I don't want to go in a lot of detail and bore you here. You can do it at your pace. Okay. Same site also has, if you look at it, right, you can also go, I want a tutorial. And then there is an XML tutorials. Okay, in a moment, we're going to talk about XML. But this is where all of the XML tutorials you have. Okay, so this is one side that's going to be, should be in your high list of reference sites that you constantly go and learn at new things.
So we need any behind password for
No, this is completely free. Okay, you can just go through it, like look at everything.
Yeah, important thing is data entry controls, right?
Yeah.
The HTML forms.
Different types are, what are properties, ID name,
Yep.
for every control, you can have properties and so forth.
Yep.
So when we talk about automation, it will come handy.
Yep. So forms, attributes, elements, what are the different input types? Right. So that's why it's an important, right? It's an HTML thing. Now, let's look into, since I mentioned XML, let's look into XML. Okay, that's another concept that you need to understand it. Okay, what is an XML? It's an extensible markup language. So HTML is hypertext markup language. XML is extensible, right? By definition, right? When you say something is extensible, that means I can add things to it. I can make it more richer, right? I'm going to extend it. This particular language or tool is used essentially to share the information in a much more structured way. Okay, so if you look at side by side, what is the difference between XML and HTML? These are the 4 key things that you need to think about, right? HTML, as I said, you can define your own tag. XML, you can define your own tags. So that's the first difference. Second difference is HTML is primarily used for presentations. So it's used by browser to display the web page. Okay, versus XML, it's primarily used to store the content. Okay, in a moment, we will look into what is the content. Okay, XML, it's essentially standardizes the data infrastructure. How all of the information is grouped together is what XML does. There was no structure into HTML. You remember you said I could put it H1, H2, paragraph, title size, any way I want it, everywhere I want. What XML allows you is through its XSD editors that you can take that XML and present into any format. Versus HTML, it's always a single presentation in the browser. Right? So that's the key difference. So let's talk about how do I write an XML. Okay. So at the underlying structure is the same. You have a start tag and you have end tag and data in between. Right? So when we looked at HTML pages, right? Right? It had a start tag, it had an end tag, and the data in between. Right? XML is exact same structure. You have a start tag, end tag, and the data in between. Okay, here's an example. So let's say if I'm trying to it's collect the information about a given movie. Right? And every movie has a director. So I said, hey, I'm going to put a start tag, end tag, a data in between. So it's going to capture that information about who is the director of the movie. Okay. You can have the same value within multiple tags, right? So you may have the same person directing the movie as well as acting in the movie, right? So I can define my own tag. One is a director, other one is an actor. Right? You can do those things. The difference between the XML and HTML, remember I said HTML is not a case sensitive. So capital B and a lowercase b is one and same thing in HTML when you put into the tag. Versus in XML, if I put it a capital letters versus a lowercase letter, those are 2 different tags. Okay. So that's why you need to be careful when you do an XML. Your tag cases needs to match completely for its start tag and end tag. Right, so I can't do it start tag as a city and then put an end tag as a /city because those are 2 different tags. It's going to give me an error. Okay. Only difference is if there is no data, I can abbreviate the tag. So if you look at it, there's no data, right? It's an empty tag. Start tag, no data, end tag. I can abbreviate that to be like this. So if you see a tag in XML like this, all it says is it's exactly equal to this, but there's no tag in, there's no data in between. Okay. So you can have attribute. Remember, like I said, in a paragraph, I showed you alignment I want to do in center. That was nothing but an attribute. Same thing, a tag can have an attribute by a name and a value pair. And I can define whatever attribute I wanted. In HTML, you can't define your own attribute either, because everything is fixed and defined. But in XML, I can do that. So all it just says that, hey, there is a city called Embryville. And the zip code attribute for it is this particular. Okay. So they are usually attaching the additional information, just like what we had a paragraph have do it alignment. Okay. So it will also follow the same rule, nesting, right? So if you look at it, I can have a book, title, and author, all those things are there. Within the book, I'm using title and author as a nested element. But each one has the same order, last in, first out. Right? I cannot do a crisscross nesting just like I couldn't do it in HTML. Okay. If you're trying to look at it visually, right, how the information is structured. So think about, right, I had a collection of books that had two books, book 1 to 3 and book 555. Each book had an author, title, and year. This book didn't have a year in which it published. It had only author and title. Right, so this will be an empty tag. Let me finish this point, right? So when we talk about, right, everything has to have a start tag and an end tag. Okay, everything has to be clearly nested. We talked about, right? No crisscross, last in, first out. Okay, all attributes that I do, it has to be in a quotation mark. Right, so when I put a zip code, even though it was a number, I put it under quotes. Irrespective of that string, number, everything you have to put in a quote. Okay. And then when you're authoring an XML document, each document has to have a unique first element called a root node. Okay. Let's look at an example. Right. So in this case, right, this is an XML page. It has a unique root node, which you can have only one in a given XML file, right? So in this case, XML document, I have a books as a root node. So if you notice it, I cannot define it books again because it's a root node. Then within that books, I have 3 books. So this is nesting, right? So if you look at it, right, the book node is getting repeated 3 times. Right? Then inside that, any attributes has to be in the semicolon. I'm sorry, inside double quotes. Right? And I can have as many attributes I wanted for a given thing. Okay. Everything has to be properly nested, last in, first out, right? So all this 3 is inside a book, right? So each one ends before the next one starts, right? And I cannot have a second book till the first one ends. Okay. So that's an XML. Now, each one has a unique string that you need to put it also at the top, along with the root node, which essentially tells the XML parsers what version of XML standard I'm going to apply. This one is a 1.0 standard. right? If I change that to 1.1, then all of the rules for XML 1.1 standards will be applied for this page. Okay. Another interesting thing is you can actually open XML files in the browser and see it. Okay. So let's say, okay. So if I go, okay, so let's say I'm going to go and open this with a Chrome. It will show me okay. It says that this XML file has no style information, so I'm just going to display the XML. Nice thing, if you open it in the browsers, the XML, it allows you to, like, it's kind of collapse these things so that it's easier to read it. If there's a lot of text in it, you can narrow it down, right? There is only one root node. Okay. Now, that's the thing, right? Take a look at it. What happens in XML world when I don't follow the rule, right? So let's say I try to mismatch and I try to do something like this. Okay, I'm going to save it. I go back and say I'm going to try to load it. Watch what happens. Okay, browser told me, hey, you didn't structure XML properly. Go look at the line 10, column 28. It has a mismatch and it tells you the whole thing. This is the mismatch. You can go back and fix it. Okay, I won't be able to do that. Now look at that. The data didn't get displayed properly, but it told me an error. Right. Same thing if I would have done it in this page, right? Let's say if I was missing this tag altogether. Okay. And then I try to, like, let's go ahead and display my second page into browser. Look at that. It still showed me a blank page. It didn't give me any error. Right? It's something goofy, right? So I can look at the page source. It still shows there was a source, but it failed to load things. So I couldn't know what was wrong. Right? I had to manually look at it and inspect it to do it. Versus in XML, it gives me nice things. Okay. Any questions?
So this is making life easier, right?
Yeah, because it's not presentation, it's a data structure. So it's telling you, it can follow the rules and tell you what's wrong. The other one is presentation. If it's missing, my browser is not able to parse it. So I don't know what will get displayed. Right? So play around with it, right? So play around with HTML and XML this way and figure it out. So here's what I want you to do it. So write it down, right? And this is the homework that you need to do it between now and Thursday, right? So I'm not expecting it to be done tomorrow. Okay. I want you to create at least one HTML page for yourself. Okay. Which should essentially display one image, ask user to enter one text, right? So let me do this. So Okay. So if you want your own picture, you can put it. If you want to grow a picture that you really like it of an items or collections, put it. So you need to do a HTML page with this 3 pieces of information. Okay. Also, try to create a form, right? So that's an extension if you want to do that, right? But as Harshal said, you should get familiar yourself with the extensions and forms. Okay. Second thing. Okay. Okay. So I want you to create an XML file which talks about the places that you have visited in the last 5 years, right? So for each place, okay. Country where it's located. And so, for example, if you went to New York, right, and you said, hey, I went, looked at Statue of Liberty, I looked at Empire State Building, I went to the Times Square. Those are the 3 sites that you saw it within New York City, right?
We will send you in the email. So that you don't forget.
Yes.
Okay. So these are the 5 pieces of data that you need to put it. Okay. It's good. Any questions?
Yes.
Yes.
So the script remains the same for the HTML and the XML.
This is 2 different homework, right? So this is
Yes.
an HTML page. And then this one is you need to create an XML page.
Yeah, I'm just asking, is the HTML script pretty much stays the same and we just input the information in the middle?
No, you have to create from scratch.
You have to create a completely new page. Following up, remember how I showed you guys to create an HTML page?
Right.
That's what you need to do it, right? So you will still have title, body, all of those things.
Okay.
Right, so
So
when you,
no matter what you write, like the title and body has to be there.
yeah, that's the structure of HTML page,
That's what I'm saying, that specific structure or the script.
right? So like you'll have a header, like what I'm showing on the screen, and you will have a body, right?
Mhm.
And then all I talked about it is what information you need to capture into the header. Right? Because header has a title, information, and then what should be in your body.
Okay.
Any other question?
No.
So image is also part of body.
Yeah. That's where you need to, like, go to w3schools.com, learn it, understand how the images can be put an image, and do that.
Yeah, generally everything goes in the body section.
Yeah.
Okay, except the title.
Because body is not-
Yeah.
So for the second one too, if we go to schools, we also like, it's also going to show the format or like.
Yep.
the city,
It's again, remember, XML is an extensible markup language. So you define what you want to call it, city is. Capital city, lowercase city, C capital, it's your call.
So can I see the example of the one?
Yeah.
Yeah.
Marshall will send you with that.
We will send you. Example.
Right, so.
Yeah, you
But
look at
like,
this.
so like the thing is, like this one has 3 different like books. But then like for the homework is, you know, it's a different list, so.
Yes, so this one has 3 books. Something similar, you will have it, the places you visited. Right, so places probably is going to be the root node, and then you will have different places underneath that.
So then like the place would be, like the name of the place would be the data, and then before that would be like place, I mean.
That's for you to figure it out. That's what I'm looking for you guys to look at it and say, if somebody tells you you need to create XML file to contain this. Right, can you go to W3 schools, you understand how the things are structured, what you can do it. All we're looking at is, can you convey this information? Just like what this was books, right? The books has ID, location, where it's located, the author, the title, the year it's published. Right.
I mean, we gave you in the binder, you have the examples as well.
Yeah.
Right? Just follow that, think about how you just start.
Yeah.
Even if you don't want to do it. You have it in your video.
Okay. Any questions? Before we jump into the next section. All right. Yeah, so something to figure out. Okay. So I'm gonna,
We'll take 5 minute break.
you wanna take a break? Okay, let's take 5 minutes. It's 10:28, right? You wanna take like 12 minutes, get them till 10:40, and then you start with JSON followed by the database.
10:40, yeah.
So,
Actually, and, we'll come back.
yeah, stretch your legs for 10 minutes, and then we'll come back here.
Okay, so I think Dilip talked about the XML, HTML. Hopefully you guys understand what it is. So HTML is for building the websites, like web applications and so forth. XML is for exchanging the data through via web services, right? So we'll talk about web services tomorrow. But it's mainly used for exchanging the information, storing the data, and so forth. For that. Now, when we talk tomorrow, in order to test the web services, pretty much you need to understand the XML because you need to create the test data using the XML. You need to interpret the test data or whatever the response coming back. You need to be able to read the XML and figure out, hey, is the information coming back properly or not? Okay, that's the whole point. We are going over XML. Similar to XML. Okay. All right. Give me a second here. Okay. So similar to XML, there is another format you will run into. for exchanging the information between systems. Okay, so XML is used for web services, okay, for data exchange. Similar to that, there is another format called JSON. The full name is JavaScript Object Notation. Okay, so there is another format that you will come into that you need to understand. So XML is used for SOAP-based web services. So there are a couple of standards for web services. Okay, one is a SOAP-based services, and second one is a REST-based service. We will talk a little bit further tomorrow, but I'm just giving you some idea where these things are used. Okay, so there is another format called JSON, and it is used for web API or REST-based web services. Okay, it is. So let's take a look at it. What's different between XML and JSON, right? Because that will give you a little bit more idea about it. Again, JSON is very similar to XML. It's very similar. Okay, XML is tag based. JSON does not have tags. It just have a name and value data pairs. So kind of like an example here, right? So you have a name, and name is called John, right? Age is 30 and car. So these are tags. These are actual name and value pair, data value pairs. Okay. If you have to write this in XML, how would you write it? You would say name tag, then closing, starting, closing tag, and then value would be John. Okay, so that's how you write it in XML. But here, JSON does not have tags. Everything is in double quotation. Okay. It is a plain text. Now, JavaScript is a programming language, right? So JavaScript object notation. So it is built on top of JavaScript, basically. So it uses syntax similar to the JavaScript programming language. So this is a syntax that is used for JavaScript. So programmers pretty much, if you know JavaScript syntax, you can do a lot more with the JSON. But for as a QA, you are not programming anything in the JavaScript. Okay, that's a good part. Only thing you are trying to understand is how the data, how you can create the JSON files so that you can create your test data. And when you are testing the web service, so you are creating the test data files, submitting for the web service, and then reading the response from there. Okay, that's all you need to know from the JavaScript standpoint. Okay, so let's take a look at it a little bit further. Okay, so as I said, data is in the name value pairs, name and value, name and value, name and value. Okay, so this is name and value. Data is separated by commas. XML, you have tags, there are no commas in XML, but here you separate the values by comma. So their first value name John, age 30, separated by comma, and then the last value is car. No. It's a curly braces hold objects. Okay, so everything you had a root tag, right? In XML, here you need to put the curly braces when the beginning and at the end. Okay, so that's a little bit difference. Square brackets hold arrays. So let's talk about in the next slide. Okay, so I'm gonna hold on that. Any question on the syntax here or the data or name value pair? Is everybody clear with the name value pairs?
So after comma, each time we have to put some space there.
It doesn't matter. It will, if you put space or not, it's perfectly fine. Because name and value, that is the data. Spaces are not data here. Now, if you put space here, basically, I think it will still ignore. Okay. But if you put space here, then it becomes part of the data as well. So like a space John, if you in this case, so it will consider space John as your data value. And that could have could have implication on your testing because the space John will go, you are sending for web service testing and So I don't know how the other system will behave, who receives the data, because they need to strip out the space from the data values. Okay. But if you put after comma, you can put space or not, it doesn't really matter.
Oh,
So why on John you have quotation marks, but on thirds you don't have quotation?
Yes, so I'm going to talk about the data values. Remember, this is built on top of JavaScript programming language. And the programming language has certain syntax, right? And there is a difference between these values, right? Here. So let me talk about it in the next slide. So since it's built on the JavaScript, it has some data types. Okay. XML does not have data type, right? We all know it. Everything is between, you don't put, you don't distinguish between numeric values versus strings, right? But here you have different data types that you can specify. So number, when you are putting a number, it shows you don't have to put in the quotation mark. Okay, so it's a 30, it's a number. Now, if you put quotes around it, it will treat as a string. So this 30 value so this is the number, right? That's what we are saying here. Okay, string is always surrounded by quotes. So if I say age and 30, I can say that, okay, this way. But then the other system will interpret as a string instead of number. So they might have to do some translation as well when they are reading this JSON file. Okay. Now it's a JavaScript, is again the object-oriented programming language. It has a concept called object as well, right? So this is a type of an object in JavaScript, okay? JSON object, and you can say employee, and then you can have this syntax curly braces, and you specify all the basically data values over there. Okay. So there is another type called array. Typically, array is a list of values. That's what the array means. It's a predefined list of values. So here I have 3 values. So array syntax is something like this, okay? A, B. So I have 2 values in this array. And if I am defining some array tag, so I can say list or something. So this list contains 2 values, and it is basically in the square bracket. So that will mark it as an array. Okay, so that's the list of values. In this particular example, I have employees, right? In this example, I have employees array with the 3 values of John, Anna, and Peter. Okay, so there is a type called array, and as soon as you see bracket, hey, it's an array. Okay, that's how you can read it. There is a type called Boolean. Boolean has value of true or false. Okay, so here it shows a true value, but you can put it as a false. That cannot be any other value. Okay, now you cannot say if you put sale and say X or something, this one will cause an error for JavaScript, this JSON file. Okay, when you read it. Now there is a special type called null. Null means empty, nothing. Okay, so if you want to specify something doesn't have a value, you can specify a middle name and then null. Null is a keyword or reserve word, just like true or false within the JavaScript. It says that this middle name does not have any value.
Means no middle.
No middle name. Well, middle name does not have a value. So I can say something like this, right? Middle name. Okay. Okay. So here I can say empty. Generally, when I don't want to specify any value, I can just put 2 double quotes. It's an empty value, right? But then program interprets differently, these values. Empty value versus nothing, null value is a different interpretation. Okay, or I can say null, middle name is null. Okay, so again, that's the structure the programming software has defined. Whatever value programming software accepts, that's what you need to send in for your testing purpose. So you need to have the right format created. Whether you send in null versus this empty quotes, it has a different interpretation in the programming world. Okay. Again, this type of things we will talk a little bit further tomorrow when you are testing the web APIs, and you can play around with it and see what it does. Good thing is there are only 5 different types, right, that you are dealing with here: string, number. You can have an object, right, like this, or an array, list of values, Boolean or null. Total 6 types.
So if there is a, John is the, think about like that is the first name. If there is a last name, so we can put it,
Yeah,
like a space,
yeah.
then put the last name, or we have to do like,
Oh, you just create so you create F name or first name,
uh-huh,
then say John,
uh-huh.
then comma, put
Oh.
a second thing, last name, and say XYZ. So
So
those
we
are
can
different values.
combine with that, right?
Well, it's again, yeah, how you want to present, how you other system is exchanging. That's how you can do it. You can just say full name. If you just put name,
Oh,
then say John Smith. Just type it in John Smith.
so
Then
you have to give a space between John and Smith,
Yeah,
or
yeah.
just write John Smith?
no, you can put space between
Okay.
that.
Okay.
Yeah, so it can be something like this: John space Smith,
Oh,
right? So it can be like that.
so full name. Okay.
Yeah. The name will contain John space Smith, which is perfectly fine.
And another question.
Yes,
The square bracket will stay inside the curly bracket, right?
yes, everything has to be within curly brackets. So your JavaScript, the JSON file starts something like this. You have curly brackets starting, beginning, because remember the root tags, right? That's what is very similar to that. Then you have index, and I'll show you one example, I think on the next slide as well, how it compares with the XML as well, quickly. But then you start with what your name is. Okay, and John, comma, oops. Then comma, then you have a second tag, address, let's say address. Okay, and then whatever the address is, then comma, then you can say, if you are adding a list, right? So let's say this is a list. Then you will put these brackets and put all the list values. Okay, there is a one more. So this is 1, this is 2, then comma. Okay, and then you will have something else like that. So you keep on going, just like XML structure. Basically, you can nest the tags as well and everything else. Okay. So it's way similar to the XML, but remember there are no tags. So the file size, this format is getting very popular with the web services for exchanging the data, because it is very compact, meaning there are no tags. So when you are sending over the internet, the file size goes down significantly.
Yeah.
Okay, because of there are no tags. And that's the reason, I mean, it's very, very popular, because you don't have to add this extra greater than, less than symbols, all the slashes and everything is gone. Okay. That's the reason I think most of these modern web services, they are built, they use JSON format for exchanging the data. But there are certain type of services, they also use XML because they were built differently in the past.
So is it like a specific browser are there for rendering the tree for JSON or XML, or it is like every browser can do it?
No, well, browser will not do anything, just like XML. They will not be able to interpret JSON. It's all about the data exchanging, right? So XML, what did the browser did? It just rendered as is. Then they did not do any formatting or anything. Same thing with the JSON file. It will just show you the JSON file, all the data. That's it. Is that your question?
So it is not going to render anything on the web page, right?
No,
It is
no.
something called, it is more upon like server side of thing.
Yeah, that is correct. So if I create a simple file here, right? So I'm gonna create. So by starting bracket, let's say name. Okay, and it says John. And then address. 1 Riverside Plaza. And now I save it. I can save it simply. They put it as typically this file as a JSON extension, JSON. Okay. And that's pretty much it. Now, if I go here, let me find my test.json file. See if I can open in the browser. Yep, trying to hide it. But with, see if I can find Google Chrome. This one will not do any interpretation.
Oh,
Okay, it will show you raw data because this is all about data. Okay, kind of like XML, you will see that you will see the structure, but here it just dumps the same thing. That's why there are specialized tools. We will see tomorrow. Soapman, Post UI, Soap UI, and Postman. Those are different tools you can use for this type of things, testing, creating the test data and so forth. Okay, but it will not do any interpretation. It will just show you raw data at this point.
that's why we should know this, right?
Yes, so you need to know, understand the syntax,
Yeah.
right? And you need to know how to create the test files so that you can send the test data to the service and get the response back and interpret it, what is sending you back. Okay, so these different formats are very important for you to understand.
Yes, think
Can we
about,
have an HTML file where we get, calling the data from a JSON file or something like that? Can we call that?
No, the HTML is for building the web pages. It is not for transferring the data or anything. Okay, XML and JSON are used to exchange data, but not HTML.
so think about the example we talked about the Amazon, right? I'm trying to do the payment. It requires some credit card information and everything to be sent to the payment gateway. Right? That's where potentially you can use either XML or JSON format. It says, this is the credit card number, this is the name of the person holding credit card, this is the amount that I want to charge it, here is the expiry date, here is the CVV code, here is the validation of zip code to the payment system, right? So that you're sending it from the Amazon system to the payment gateway, some data, and the way you can do it is you can do it through the JSON format or through XML.
Okay, so it's a data exchange format. Okay. All right, let's come back here. So let's take a look at this example, right? JSON versus XML. So it gives you a little bit context. So I have example for XML below, right? So this is how you're writing your root. This is your root tag. Then you have each employee, and they have first name, last name, and so forth. Same thing is written in JSON, right? Say this part is JSON. This part is XML, and you can compare, right? Only difference is our first name is in the quotes, and the values are separated after colon. And then you have last name, right? First name, Anna, Peter, last name, and this is an array of the employees, right? That's how it is written here. Okay. This tag tells you it's 3 employees in the array, and they all have first name, last name. So that's exactly same as XML over there.
It's more compact.
Yeah, it is more compact, right? So it reduces the size maybe by one third,
It's space.
right? So that's the reason, because if you imagine you are sending out thousands of records over the internet, it's a one third of the size, so it goes very fast. It's a compact format. Okay. Again, you may or may not create the format from scratch. Developers might help you, but you should be able to read the data. That's your goal here. Okay, you are not a developer, you are as a QA, but you need to understand these different formats so that you can test different things. Any question on this JSON?
If it's, as you said, if it's does this exact same job, JSON and XML, then why do people still use XML?
Oh, because the services are built over the years, right? Web services. Now, so there are thousands of, I was working at BMW Financial, and they had thousands of services. They all are XML based. Okay, so you cannot just overnight change it to the JSON, because those standards, those SOAP-based standards require XML data exchange only. Okay, those services are built on SOAP standards. There are two different standards for web services. One is SOAP and one is REST, R-E-S-T, REST. The new services most companies are building today, they are building on REST-based standards. Now, REST-based standards, meaning certain specification, they support both XML and JSON format. Okay, so again, it's a company preference, what standards they have in place, so you never know what they're going to be using. But most of the services exist today, they have XML based format, data exchange. Okay, but the new ones, they are using JSON. If they are most of the new ones are being built today, they build using JSON. So you need to know, because depending on your client, company, you will have to understand more. Okay. All right, so let me just go a slide quickly, right? Let's highlight the difference and hopefully you guys understand. So both JSON and XML are self-describing, human readable, right? Based on the tag versus the actual name value pairs. Both JSON and XML are hierarchical. So nesting, you can allow it values within values and so forth. Both can be parsed and used by lots of programming languages. So they are not dependent on what programming language you are using. You have program written in Java that can create a JSON and send to the Python program. The Python program can interpret JSON or XML both. Okay, so both are programming language independent. Okay, and both are available on internet, XML, HTTP request, or internet data exchange. Now, what's the difference? Right? Doesn't use end tag or tags, right? JSON is shorter, quicker to read and write because they are very compact. JSON can use arrays. XML does not have arrays. List, right?
Oh, yeah.
The XML does not have arrays, but JSON does. Okay, so that's the additional feature JSON brings. Now, XML has to be parsed with the XML parser. So in the browser, when you saw it, the parser was actually reading your XML file and showing you in a nice little format. So it has some versioning. JSON can be parsed by standard JavaScript function or any program that you want. Okay, so these days, all the programming languages have built-in JSON functions. So you just read that file and load it into memory very quickly using those functions. Okay, but the JavaScript is primarily used for JSON. Again, they both are data exchange formats, so it doesn't really matter. From your testing standpoint, as I said, just focus on understanding the format, how to create test data, and how to interpret the response, the results, basically. All right, any question? Okay, so your homework would be create a JSON file, right? The same homework that you have for XML, just create in JSON as well. Okay, so that same homework would you have to write it in JSON. Everybody good with the homework?
Could we, is JSON on W3 school too?
Yeah, W3 School has everything. So if I go back here and tutorials, so you will see HTML, right? JavaScript, JSON right here. Yep. All those things. Now JSON has a little bit more. I don't want you to worry about more stuff. I think you talk about intro and data types, and everything is programming stuff. Other stuff is like a programming. Okay. You probably will not use these things, just stringify and other things. Okay, so if you refer to the booklet that we have, I think that should be good enough, but you can always come here and understand, because otherwise it's more like a programming concept. Okay. Yeah, it just talked about database more programming. So what I showed you is good enough for you.
So JSON is not in my folder, on the slide.
It's not, so I already shared a module. You guys all have access to that folder, right? Yeah, just go there. There is a module number 11. I think it's already there. Whatever I'm showing.
So our 11 number is there.
Some of the folders that we have the JSON chapter to send them.
No, it's already there. So I sent you guys a link to the basically digital documents. Yeah. So digital documents link, right? It has all the modules and JSON is there.
Okay. But
Okay.
it's not printed in here.
Yeah, it may not have, because we have added later on. So yeah, that's the reason for it. But it's there in the digital document form. Okay. All right, so now we're gonna talk about one last topic for today. And so these things, the format wise, make sure you spend time, because I think these are, you need to know what we talked today. Okay, and you have to spend some time on it, understand a little bit further, and so forth. Now you don't do program, you are not programming, right? But you need to know from the QA standpoint what is important and what's not. That's what we highlighted here. All right, so let me pull up a different one here and dive into a different topic. Okay. So I think we will dive into database now.
Module 6.
Yep. Okay, give me a second. I have updated the slide, so I'm just gonna put it out latest one in there. Somehow it's not play. Okay. Okay, all right, so let's dive into the database. And then I think you all have installed software data, so we'll work through some exercises as well. So I think lecture is probably 30 minutes. I want to give you some concepts about the database, and then we'll dive into the SQL. Okay. Now SQL is a big topic, but I'll give you from what you do day in and day out as a QA. Okay. So hopefully that will give you some idea about SQL. Okay, first of all, why you need to know SQL, right? I mean, so any system that you're gonna run into or build, it all have some type of database in the backend. Anything that you do in the IT world, okay? Now, if you work with the operating system type of projects, like creating the Microsoft Office or Microsoft Windows 10 or Mac operating system like backend projects, they might have some different things. Okay, but any business applications which you deal with, they all have some type of data in the backend. Okay, and they all work with this. And when you say data, so they all have some type of database in the backend. Now, as part of your testing, when you are working those type of software development projects, right? So kind of like Airflow, you have to do some type of backend testing. Maybe create your test data in the backend. Because remember, as we are building the software, the functionality is available as you go through, right? When you are starting out, you don't have anything other than database only. So when you are creating something like user accounts and stuff, and if you don't have a user management functionality available yet, how would you create your test data? How would you set up your users? So you have to go in the backend and create your users and so forth, writing the small SQL scripts. Okay, same thing. If you don't have a dealer certain type of functionality, and you are searching for something, you have to write the SQL queries to read the information and verify things are saved correctly or not. Okay, so backend testing, data verification for applications, that's what you need to be able to do. Batch job processing. There are a lot of backend processes companies have. So like you see the web application, that is more like a front end. But I don't know, anybody has like IRA or 401k, something like that. Are you guys familiar with that? At the end of day, they present, if you go on their website, they will present you at 9 o'clock or something, update the daily value of your 401k. Right? So that's typically, there is just some big SQL jobs running in the backend. It calculates, also it runs on the stock market data, and then gives you at the end what is in your portfolio, what's your value, portfolio value. There is no user interface for any of those things. You have bad jobs running in the backend. If you imagine you are a tester on that project, you don't have any user interface. How would you test those things? It's purely SQL. Okay, so it's all backend. So you need to master the SQL for that one in order to test those things. Okay, there are reporting side of things. So in Airflow, we have reporting, right? You are selecting something on the user interface, but how do you know the data is coming properly or not? You need to test those things as a remember in our flow, there is a report section, right? And you are going through that. Without writing the query, you cannot test those type of functionality, those reports. Right? So for that, you have to master the SQL skill for that as well. There are other types of projects, data warehousing projects in the companies. So like companies like JP Morgan has a $50 million projects that or $100 million data warehousing projects. They strictly tie to the pulling the data from one system to another system in the backend. Have you guys heard the terminology called ETL? Extract, transform, and load. What it does, it pulls the data from 50 different systems and then puts it into some centralized place where you can create your reports. It's all about data at that point. Those projects are typically part of the data warehousing projects, and they data warehousing projects are $50 million or $100 million or more. Software development projects are generally $500,000 to $10 million. Data warehousing projects are $50 million to $100 million, much bigger projects. Okay. You need the advanced SQL skills. If you ever want to work on the data warehousing projects, that's just, you have to master SQL inside out. Okay. What we are talking about is software development projects here, but sky is the limit, right? When you are learning something, SQL is kind of like a skill that you want to get next. If you want to work on the $50 million and $100 million projects, it pays you a lot more money too, because it's a specialized skills. Okay, that's a keyword. All right, so that's why you want to pick up the SQL skill and master it. Okay, what we're gonna talk today is how can you read the queries, how can you interact with the database and so forth, so that you can complete your testing. Okay, and so forth. Now, typically we have completely different camp over 3 weeks or 4 weeks that gives you the advanced level skills. But here today, I want to give you some quick things so that you can answer the questions in the interview that will help you for the software development type of projects. Okay. So let's dive into what is really that you need to learn from database standpoint and what it is. So everybody familiar with the database? What is database? Right, storing the information. It's but in the terminology wise, it's any organized collection of data. That's what the database is. Organized collection. That's the important part. How can I store the information quickly? How can I retrieve the information quickly? And it's any organized collection. Now, it doesn't have to be computerized. Okay, it can be we all use like a books, telephone book, right? In the past, I don't know. I'm old, right? I mean, so we used to get like yellow pages. I think we still get it. Somebody drops it off here every year as well. They still send it, but nobody uses. I mean, those yellow pages. But essentially, it allows you to find somebody's phone number very quickly by going to the indexing and all those things, right? So we used to have TV guide as well. It used to come in the mail. There was no internet. I mean, back in 90s, I'm talking about 90s, right? So they used to send the TV guide. It lists you all the programs and send you mail you to your house. Okay. So, I mean, anything that you can think of organized collection, that's considered database. Not just a computer. Okay. But in the digital world, I mean, we all deal with various different systems today, airline reservation, if you're planning your flights and so forth, they all are database. Okay. Now, why do we need it? Anything that we want to do with the data, we need our record keeping, reports, data entry, or whatever, right? I mean, we need the database regardless. What is required when you are creating a database? What is needed, right? So you need a software, first of all, to create the database, which is called DBMS, Database Management Systems software or database management system. And that within the DBMS, you can store as many databases as you want. So kind of like a web server, right? You can create many web apps, database. Once you have software, you can create 500 database, 1,000 database, there is no limit. For the database. Now, what are the most popular databases, right? So I'm sure you guys heard some terminology here, Oracle, SQL Server, DB2 is there, Sybase. Microsoft Access is still there. But it's on the desktop. You generally, so if you are doing your own record keeping, you can download Microsoft Access. I think it's not free, you have to pay for it. But you can create your own databases in Microsoft Access and run it on your laptop. Okay. There are other ones like a mobile phone, right? All the mobile phones have SQLite database. It's free. It is installed. So any app, anything that you store in the app, typically it gets stored in the SQLite database. Then it's later synchronized with the server somewhere, whenever the network is available and so forth. There are a couple of free ones, MySQL, MSQL. What you guys install is a SQL Server. Okay, this is the one that we installed on your machine yesterday or Thursday. Okay, so we use this for practice. Microsoft SQL Server. It is free. The SQL Express version is free. There is no licensing or anything. But generally, they cost like $100,000 plus in the companies for licensing, depending on their usage and so forth. Okay. All right. So that's the DBMS software. Okay, that's what we are talking about, software. So once you get the software, what do we do? How do we create the database and so forth? So generally, when you create a brand new database, you create the certain table structure. Okay, so table. So how do we organize the information? Right, we organize the information into tables in the database. So this is what the structure looks like, right? So we have a database. And one database has tables. Table or tables, number of tables. Now, how do we come up with the table? So we look at the requirements, same requirements that are flown document, right? The designers will take a look at it and they will say, hey, I need to store the customer information. I need to store the dealer information. I need to store the lender information, the users, all those things. So they might create a table called customer or a loan, credit apps, right? This is a credit app table. Okay, then they'll say, oh, I need to store the users. So maybe I'll create a user table. That's where I'll store all the users. Then I will have lender table. Then I will have dealer table and so forth. Again, it's a design process and so forth they go through. But essentially, database will include number of tables. Okay. Now, whenever you create the table, it's going to be empty. There are no record. It's just a structure. So when you start creating the actual user called whatever S training, right? Then you will have another user called G training. All this different piece of information will become, these are called records. So one record will contain a bunch of fields or a bunch of information, right? So every table will have more than one record, right? One or more records. Now, table also contains fields. So what's the information that goes with the dealer record? You have shop name, you have dealer address, you have dealer phone number, email, all different things. So when you define the tables, you identify what information I want to store. And those are nothing but the fields. Okay, so table has fields and table has record. That's as simple as that, right? It's more like Excel. So I have rows and columns. These rows are in the record. columns are nothing but the different piece of information or fields. That's what the database is typically built on. Now, when you go down to the fields, there are additional things. What type of field? What type of information I want to store in this particular field? So if I'm storing a social security number or credit card table, do I want to store the only numbers, or do I want to store with the dash so that I need to say it's a text instead of number, right? So again, database designers will go through this process, identify what fields, what type of fields, and all those things, and they will create it. It's a whole other design process. Okay. All right. So these are fundamental building blocks of a database, basically, from our standpoint.
So fields are more than one field is inside the record, right?
In the table, when you define the table, you say, okay, I need to store, I need to create a table with this many fields, like shop name field, shop ID, address, phone number, all these fields. So I could have 50 fields or 100 fields, doesn't matter. But when you actually create information, when you start inputting the information, it becomes the records. So dealer record, right? Dealer record 1, which is German Toyota, and it has all different address, phone number, all this associated with it. It's just a terminology. What is record, what is field, and so forth. But essentially, this is what the table looks like, right? You have columns and rows. And this is something you might see. This is for sample table, right? This is what one of the table will look like. I have all the columns, which are nothing but fields, and then the records, basically. And you can have millions of records. Doesn't matter. Table can accommodate as many as you need. Okay. I think we already talked about. Now, as I said, field will contain data type, and these are different data types that you can have. Image, number, text, binary data type, char, varchar, integer, double. Again, numbers are numbers, right? So this one is kind of like a SQL terminology, SQL database. Now Oracle might be calling something else. Oracle might be calling double as a float. Okay, this one is called float. Integer, it might be calling as int. Again, doesn't matter. It's a terminology specific to the database. Okay. Char and varchar are again characters. Char means character, and varchar is variable character. Okay, that's what it is. There's a little bit difference in storage, but otherwise, essentially, I can store any text values in those. Now they have a special data type called text. So what's the difference between text versus this thing? This one can go up to 8,000 character. This one can store up to 2 gigabyte. So if you have large documents, like Microsoft Word document, you can store it into Excel. Store it into SQL Server field. So you assign the text type to that field so that I can put very big documents. But if you are storing like a first name, last name type of thing, you probably will assign char data type versus varchar data type. Now, if you are storing integers, right? Integer whole numbers, then you always know that Social Security will never have fractional values. Then you assign type as an integer. But if you are storing the amount, which has a fractional value, then you will assign the type as a double. Okay. So again, it's a design process, and designers will figure this out. Okay, what type of values we are storing and all those things. From your standpoint, you just need to understand this thing, and that's it. You don't pretty much use it. Other than you are verifying something and you are saying, hey, why the digits are chopped off, basically. I'm supposed to see 104.50. I'm seeing only 104. Even though you are inputting 104.50, it's storing 104. That's where you will say, you will question, and then you open a defect. Okay. If the user interface is not available. If the user interface is available, you are inputting 104.50, But when you retrieve the record, again, it shows you 1 of 4. Then you say, oh, but this guy something must be chopping off somewhere. You go and look at the database, maybe look at the type and it say, oh, it's integer. So it's chopping off the values when it stores. It's a troubleshooting process. But again, if you know SQL or if you have access to the database, you can do that. Otherwise, you rely on somebody else, work with the developers and tell them, open a defect. That's all you can do, right? But more you know, more it might help you for troubleshooting. Okay.
Images, so we can put images.
Yeah, you can put the whole image. You can store it right there in the database. It's like a picture, right? When you go driver license, they take your picture. Next time you go there, your picture is still there. Right? They store the image right along with your record, social security and driver, whatever is there.
We can think of database, you can think of databases like Excel.
No, Excel has a one table. Every spreadsheet is considered as a one table, right? But this is more of a relational database. So I'll talk about what is relational means. But you're organizing the information so that you can store it and retrieve it very quickly. Excel, you still have to search for it, right? You cannot write the queries in Excel. You go in the Excel and you click on find. So it will, that's how you can find the information, but you cannot write the queries. Okay, these ones are designed for writing the queries and building the apps. Excel is just one table type of thing. You cannot build app on top of Excel. But tables are similar to the Excel spreadsheet. All right, I think we already talked about data types, so I'm going to move on. Now, this is how the table definition will look like. Okay, this is how when you create a table, it has a field name, what is the field type, and how big or what values I can store, maybe up to 15 characters or 20 characters and so forth. Okay, so this is a typical definition for the table. Now, if remember, I mean, in the real life, we have 500 plus tables. Okay, the typical, basically decent sized database. 500 tables or 1,000 tables you are dealing with. That's the most common in the business world, IT world. So somebody has to create it. That's why they have a job for database administrators or database designers. All they do is create the tables, maintain the database, and so forth. Okay. All right, so we'll talk about primary key shortly. But you see here, primary key. Essentially, every table that you define has to have a primary key. So what is primary key? It's a unique identifier assigned to every record. Okay, so think about in this case, I have a student ID that I'm assigning uniquely to the student record. Okay, student particular record. So what does it mean by unique? It will never repeat. If I enter million student records, it will never repeat, or it will never be same for two different students. Okay, the student ID will always be unique in this particular table. And that you can, so kind of like an auto number, right? You have franchise number. It will never, you want to make sure it is never same for two different dealers. You can technically mark that as a primary key for a dealer table. Same thing, username. Do you think it's going to be unique in Rflon? Username, can two users have a same username, login name? Never, right? So you can mark that as a primary key in the table.
So it's like an identification.
It's an identifier, like we all have a social security number, it will never be same, right? It identifies everybody uniquely. Okay. So every table will have its own primary key, whether it's auto-generated or you can basically input something. So for students or for our purpose, if you are creating a database for people, I can technically say in the US, social security number is unique or mark it as a primary key. Okay. Now, outside US, there is no social security number,
Yeah.
right? So they have their own mechanism, so they might have something else. Okay, so let's move on. Now we are talking about relational database here. Okay. So let's talk about what is relational or what is a relationship. Okay. So let's understand the definition here because it's important. When you are writing the queries, you need to understand how the tables are related so that you can write your SQL queries properly. Okay. So tables are connected via fields within a table that are set by a pair of tables. Okay, this is the definition. But essentially what it is, so let's take an example of credit app. Credit app. Actually, let's take an example of let's say we have dealer table. Okay. And I have a user table. And dealer table has a shop ID as a primary key. Right? This is a symbol. This is a primary key we identified, right? The user table has a user ID. Primary key, right? There might be other fields as well, but I'm just talking about primary key here. So if I want to know what user belongs to dealer, to particular dealer, right? In the table. So in the relational database, what you typically do is, in order to relate the tables, you generally carry the primary key of the table to a different table. So whenever I create a new user here, right? Whenever I create a new user, I also assign a shop ID to a user record. Okay. So this one creates a relationship between these two tables because the same shop ID is assigned to all the different users that belongs to that dealer. So that I can, so now let's take a look at the definition. So these two tables becomes connected because they have shop ID column common between those two tables so that I can write my queries. Okay, now if I have to write my queries to pull the information or answer which user belongs to which dealer, so I can say select users where shop ID equals 5 or 10 or whatever. Okay, so it helps you for writing the queries. Same thing if I have a lender here. And if I want to relate with the user to identify which user belongs to the lender, like JP Morgan Chase. So all this information is there, JP Morgan Chase company. So I create a lender ID.
That will connect with the lender.
Yeah, that will connect with the lender. Again, it's part of the design process. You will not input during the design, but in order to write the queries, you need to understand how they are designing the table. Okay, so you need to understand, hey, lender ID is here and lender ID is also here. These are common, so I can write my queries. So they generally give you a nice little diagram. They generally give you a nice little diagram, which is called ER model, that explains you what is the relationship among these tables. Entity relationship diagram. That's what the diagram name is. Okay. And that's very important for you because when you are talking about find the tables, you need to understand what the structure is before you write any queries. Okay. So that's, we will talk next. I'll show you what it looks like here. Okay, so relational database, everything is related, and how you can make it related. You carry one key or have some common keys into the tables, and that's what it makes relational. Okay, Now, as I said, I'm in design process, right? So there is a process called normalization. So you analyze the requirement, come up with a logical model, apply some design principles, and you come up with the physical database model. If you attend the Columbus State Community College and go to the database class, first class, they will talk about design in one semester. Okay, so it's all focused on design. So they have one full class over one semester just for the design. Okay, so there are a lot of things goes in, but it comes with the experience as well. But goal is you analyze the requirement and come up with the database design that is a good design so that you can retrieve information and populate the information very efficiently. That process is called data modeling process or normalization process. It's just for the design. Okay, it's for organizing the data into database. It's a design process. Okay, and as part of the design, important part is create the tables, establish relationship between tables. So apply the design principles and come up with the good relational database design. The essential goal is of this design process is to eliminate data redundancy, because you don't want to store the same data in 5 different tables, right? That's the process. Also, you want to make sure the database is consistent, having a consistent design. It's not missing any relationship and so forth. Okay, so and design is database is flexible. So if I add certain things tomorrow, I don't have to change up many things. I can simply add new things very easily. It's a maintainability and so on. Okay. And it looks something similar to this when you are talking about database design, right? So here, this is the relationship between database entities. You should be able to read it. This is kind of like an ER diagram, entity relationship diagram. Okay. And you should be able to read it. There are some notations here, which I'll talk a little bit briefly, just for your understanding. So these are my table. Think of it as a table, customer and order. Now this is a logical data model. This is what they drop first. Okay, or if I have to drop, if I'm looking at the requirement, this is something I would start with on a sketch piece of paper. Okay, and I will try to identify the relationship logically between these two objects versus these two and these two. So what it says here, if you are reading it, right? Customer places one or more many orders. Okay, this symbol, this one says one or many. Okay, one or more orders. Okay. Now order is for what? For one or more product, right? So for product, I can say here or here. Then in this particular model, they have it here, right? So if you look at your Meyer receipt or Kroger receipt, you will typically see like a product ID. You will see your customer ID. They may have, but order ID will definitely be there. And then you will have order line, what the order contains, and how much quantity and so forth. So this one might include quantity as well and other attributes. Essentially, it's a logical how things are related based on the requirements that you have. So designer will start with that, and then finally they will identify the primary keys and foreign keys, because here we don't have relationship, right? Here I just have the relationship stored as a one-to-many type of thing. Okay, so here, so I have a dealer. So in our case, right? Let's say dealer and users, user. So I can say, when I start out, I can say dealer contains 0 or many users. Because I can set up a dealer without any users as well, right? First time when I'm creating, then there may not be any employees. But once I start adding them, they can have many users. Now, this is a logical thing. There are no primary keys yet. There are no relationship yet other than this symbol. Now, when I convert this into the actual database design, that's where I can identify, I have this relationship, but how do I represent in the database? So that's where I say, oh, I have a dealer ID here, shop ID. I need to, because of this relationship, I need to carry that over here so that I can relate dealer and user table. Okay, so that's the design process they go through. That's where during the design, they will identify all the primary keys, foreign keys, and whatnot.
It's like assuming that there will be, so then how?
It's not
define
assuming.
How many?
It's not assuming, okay? First of all, they will never assume. They will sit down with the user, they will analyze all the requirements. They will start drawing and they will sit down with the customer. Hey, this is how you think. We'll have dealer with the many users, and they will start drawing on piece of paper, right? We're sitting with the business.
Oh.
Yeah, it's a design
So
process.
how many user will be there that you just will put some?
Well, doesn't matter, right? If they have 0 or many, all we are saying is they may have a user, may not have a user. So all it says is if the shop ID is German Toyota, I may or may not have any user related to the German Toyota for entry in that user table. Now, as soon as I create a first user for German Toyota, it will be assigned a German Toyota ID, shop ID with that user. Okay. Again, you need to understand the process, but look at the ER model. Essentially, you want to understand this type of diagrams. You want to ask for it when you go on a project. They say, "Hey, can you write the query?" Say, "Hey, give me some design details." I cannot write it with it. I need to understand how these tables are related, and they will get you, oh, we have diagrams for it. Okay. But essentially, when you talk about physical design, this is a primary key, right? So you have every table will have primary key and how they are related. So here, book is carried to the chapter table so that I can relate, hey, where this chapter belongs to. Or this book have how many chapters in this book, right? So every time you create a chapter record, you will say, okay, it has a book ID so that I know this book has this many chapters. Same concept, dealer, user. Okay. And this is how the ER model will look like. Again, every company has their own standards, so, but it will be something similar, this foreign key, primary key type of thing. Now, what is primary key? I did not talk about it, right? So this is a primary key. Now, when you carry this to second table, different table, in this table, chapter table, this is called a primary key, which points back to the other master table or parent table. So foreign key and primary key, that's a relationship. That's the one you can call it. So book ID in the chapter table is called a foreign key because it points to the book table. Okay, that's all it is, foreign key and primary key. Now there are different types of relationship.
So foreign key means the connection between those two.
Yeah, so here, dealer, right? So let's go back to dealer. I have a shop ID. I have a user table. User has a user ID. Right, this is primary key, but I also have a shop ID here.
Shop ID is the foreign key for the.
So shop ID, this points to this table, so it is called foreign key
For the
in the user table.
user.
Yeah, this is a primary key, okay, in the dealer table. But this points back to here, so it's a foreign key.
Because of the shop ID, the user table is getting to connected with the.
Yeah,
user,
yeah,
right?
it's a relationship, right? So it's a foreign key, primary key relationship, or primary key, foreign key relationship. Okay. So everybody good? All right. Now, again, there are relationship, right? So there are different variations of the relationship. Let me talk about most common one. So when you say relationship, needs to work both ways, right? First of all, because relationship, it's a one-way relationship. There's no use. Okay. So these are different notations you might see. So first notation, again, we are talking about entities here. Okay. So I can have a dealer, user. Assume there is a dealer and user. So what it says is one dealer can have one user only. I cannot create more than one user for the dealer. That's what this relationship shows. If I see this notation, that's what it means.
That is the condition.
That's what the rule that would be implemented in the system. I cannot create more than one user for this dealer. It has to have only one user. Okay, but we know that that's not true in case of our flow. Right? In case of our flow, this is the condition that we have. Dealer and user. I can create one or many users. Okay. Now again, I said relationship works both ways. So user belongs to only one dealer. Do I have one user working for multiple dealers? No. In our flow, we don't have. So you have to read the relationship both ways. User belongs to one dealer. Okay. Now, when I say dealer here and user here, what does it mean? So dealer has one or many users,
Users have also.
right? And user belongs to one or many dealers. Okay, which is not true
For our flow.
for our flow, right? Again, you have to look at the different use case or requirements and see what makes sense.
So if it's not true, you couldn't do so.
Well, then if systems allows one user to be associated with many dealers, how it can be done in the Rflow? Hey, have you guys created any user for dealer in Rflow? So when you create a user right now and you select a user type as a dealer, it is asking you to pick the shop ID.
Yes. Yes.
Right? Now, if I need to enforce the last condition, many to many, when I create a user and select the user type as a dealer, then I should be able to select multiple dealers. When you are designing the web app, you need to associate that user with multiple dealers. Right? That's how your design will change upfront in that case. The web page design. But that's not what we have. But that's the only way you can associate same user with multiple dealers when you are creating a user. So I can pick a German Toyota, I can pick somebody else, and maybe two or more, who knows? Right? So design will change, but now if you see only one, that means you have a defect right there. Because your requirement should say user can be associated with one or many dealers. Okay. So these are the common notation here. Right. And that's what you're going to see on the diagram. Okay. When you are seeing the bunch of entities and you're going to see one to one, one to many, then you understand, okay, this table relates to here. That means there is a foreign key, primary key relationship here. And I can write my query accordingly. So that means I have one dealer, but I could have multiple users associated with it. Okay. All right. So relationship, if I in this example, right? So what's the relationship here? When you guys look at this table? So department record, instructor records. And you see here department number, even though it's not the same name, but I have same department number, I can have carried over to here that ties back here, right? So I can have queries created for that. Okay. Even though it's not a same name, you don't have to have a same name. So that will make it a little bit more confusing, right? I can call X number, who cares? So unless you see the diagram, you will not know these tables are related. Okay, when you query this table, it says X number. But if you don't have it on diagram, how would you know this X number points to this table or something else? Right? So that's why you need to have good diagram, data model diagram that can tell you this is primary key, this is foreign key, and all these things. Okay, I think we already talked about primary key, foreign key, but here primary key is not like a one column. You can have more than one column as a primary key. Okay, it's called a composite primary key when you have more than one column. Right. Now, what does it mean for relationship then? So if dealer table has a two column as a primary key, and you want to relate to the user table, I need to carry two things, two columns to the user table instead of one column.
If both will connect, then only they.
Let's say dealer, I don't have shop ID, maybe name. Okay, this is a dealer, this is a user. And let's say address, which makes it unique, right? So I don't have shop ID, assume we don't have shop ID. So these are part of the primary key. Combination of that, those two columns is unique. So I can mark both as a primary key. Okay. Now when I relate to the user, I need to carry both as a to the user table to relate with the user. Okay. So the user table will also include dealer address, dealer name, along with the user ID, whatever is there. So now these columns both are considered foreign key. The combination of both considered foreign key. That points back to the dealer. Okay, so there are implications. If you have more than one, you have to carry those two columns everywhere, wherever the dealer is related.
Yeah.
All right, so that's the drawback. That's why you generally put one auto number or franchise number, something that can identify uniquely. Okay, when it goes to more than two, it's very difficult to maintain. Because if you update the address in the dealer, you have to update it in 5 different tables. That's why we generally don't carry more than one column. Mark something unique, maybe assign auto number to shop ID, just like shop ID, and carry that over to the child table. All right. So we all understand foreign key, hopefully by now, right? So when you apply the design principles, right? This is the table that's given. When you apply all these different design principles, you will have 6 different tables. Okay, so generally, this is a big giant spreadsheet. So we are talking about Excel spreadsheet, right? You are repeating so much information here. See here. Let me see if I can zoom in. Okay. So I see Joy Herbert information is repeated, right? Many times campus address is repeated, phone number is repeated, all these things are repeated. In Excel, if you have to create this type of thing. But repetition is not good. It requires more storage, and storage is money as well, right? You want to minimize those things. Plus, I cannot find the information, cannot update it efficiently here. If I have to change the address for the student, I have to update 10 different records and so forth. So once you apply the design principles, this is what this information will look like. Okay. You create a bunch of tables, but it stores the information only once. Okay, all the records, there is no repeating information here. It's all related. Okay, that's why you spend money on the database. You can retrieve the information faster, organize it a lot better, and so forth. Okay. All right, any question on the design?
So we are doing this like separating the tables for more clarity. Like,
yeah, organizing the information, right? Once you organize it, you can build your application like Rflow, which can populate these tables efficiently, read the information efficiently via queries and so forth.
So easy to access.
Yeah, easy to access, easy to populate and so forth. Easy to update as well. That's the whole point of database, relational database. Okay. All right, so let's talk about where the SQL comes in, right? So okay, so assume all right. Okay, somehow this guy is running slow, so we'll just try it here. Okay, so this is our Rflow database. Okay. So what are the things we are doing on the web page? So you guys understand CRUD, create, read, update, delete, right? So when you say create, what action you are doing? Give me example of creating Rflow.
Creating
New application or new dealer, right? Let's take to the dealer. So I'm creating a create dealer. So I go to the dealer page, fill out all the things, and when I click save, the information will be stored. Record is created for dealer and the information is stored. Okay, read. Give me example of read. What do I mean by read?
Only you can read and do it.
Give me example. What how do I read the information?
Searching a dealer.
Searching a dealer, right? So when I type in dealer name or something, if I'm finding, I go to the dealer search page, and when I type in whatever is partial name, right? At this point, that all the matching dealer that comes out, so search or read here. So information comes out from the database for the dealer. Okay. How about update? You are adding a new thing for update. How do you do update in the Rflow for a dealer? So you search it, right? First, so I go search it, find existing dealer, then I go to the dealer detail page, and then I change something. So this is my update, right? And what about the delete? There is no delete, right, in Rflow. Is there a delete? Right? But delete is essentially removing the record, removing dealer. Okay. So let's say delete here. So essentially 4 things your application allows: create, read, update, delete. That's why you have CRUD. And 4 actions you can do. So when you are talking about SQL, okay, so these 4 actions, first of all, you can do only via SQL. Okay. You know, if you want to do something with the database, you have to use SQL. So essentially what is happening when you are saying read, right? Clicking the search button, what happens is the program executes a search SQL based on the partial name that you supply, and it will create a SQL command in the backend, and it will find a matching dealer and send you back the information. That's what it happens. When you are clicking on save, it executes some type of SQL command in the database with all the information that you have filled out on the form, and then it will create a record and gives you the shop ID or franchise number in the back, right? Because you should see unique franchise number, right? Same thing with the update command. There is a SQL command that is getting executed, and it's being updating the information. Delete, again, it's the same thing. Good thing. So there are only 4 commands that you are dealing with in SQL. Okay. When you are dealing with the data, so create, read, update, delete, you have 4 different commands. For read, the command is called select. Okay. That is the one command that you have to master. For delete is the delete command. Okay. For a U, it's an update command. And for C, it's an insert command. 4 commands. If you master this, you can pretty much deal with any CRUD type of web apps or anything. There are 4 commands to master. Now there are variations here in the select. Other ones are very straightforward. But you need to understand the database structure in order to work with any of these commands. Okay, database structure and so forth. These are very straightforward commands, and I'll show you example here. You can practice on your own afterwards. Select I will show you as well, but there are a lot of variations here. Okay, for the select. So let's see what these commands are and what the syntax looks like. So we'll start with the read. When you are reading the information, use the select, right? So choose a subset of fields from one or more tables. You are pulling the information from one or more tables, okay? The simplest command is select whatever, last name, first name, whatever the field name is. And then let me come here. So there is a syntax, okay? So select, so general syntax is like this. Select, then the columns or fields, whatever fields, okay? Then you have from what table or table name, all right? And there is some additional filtering that you can apply using the where clause, okay? Where and then condition, logical condition. Okay, so that's the standard syntax. As I said, there are a lot of variations, but this is the simple one that you can deal with. So where is a Boolean expression or logical condition? You guys all understand logical condition, right? What is the example of logical condition? X is equal Y, right? If this is true, then this condition is true, and it will return you the results. Okay, so X is not just X is equal Y, where dealer name equals German, or dealer name like German percentage. So that condition is true, then it will return you all the matching dealers. Okay, so there are some variations there, but I'll show you example here as well. Okay, so let's take a look at this example. So here it says, so I have this table, right? This is a table, but this is my SQL statement. Select star, star meaning all the columns. Okay. If you want to return only title and price, then you can say select title, comma, price from textbooks where category equals computers.
Where is the condition?
Where is the logical condition? So it says category equals computers. So what it will do is it will look at the category column, and wherever is computers, this condition will return true. So it will return Java intro and advanced C in the results, search results for this thing. So that's why you're gonna see these 2 records being written in the query. So if I'm searching from the browser, and if I select category as a computers, browser will create a SQL command, your application will execute this type of query in the backend, and it will return you 2 different records in the browser.
So that's a formula.
It's not a formula, it's a command. This is what you need to master from the syntax wise. But this is the most simplest command. Select star from whatever, where this thing equals something. What is category? It's a column name. Okay. You can filter based on the values in the particular column. That's what we are doing when you are saying, yeah, category column. Okay. Let's take a look at another example. So select, now I'm selecting specific columns. Select title, price, publisher, title, price, publisher. So 3 columns. From textbooks table, this is my textbooks table, where price is less than 110. So it will look at the price column, and say wherever it's less than 110, it will match it, and it will return in the result here. Got it? So it's all about filtering, mastering what you are searching for. Again, you are not programmer, you are looking from tester, right? So from testing standpoint, if you are verifying the dealer search results, you need to be able to execute simple commands and say, hey, am I getting the right results in the query? If you don't have a web page and so forth, right? Half-baked web page. But you run the query, similar query in the backend saying, hey, my result doesn't match with what's displayed on the web page as well, right? So maybe they have a different query, or maybe there's a bug in what developers do. So this is called backend testing. When you are running this type of commands in the backend to compare the information on the web pages and stuff, it's called backend testing.
And for this example, since the condition is price less than 110,
Yep.
we focus on the price. We'll not worry about the publisher and all those things. Right?
No, it's the filtering condition is your important, right? So if you are looking for dealer search, so you're gonna find, okay, dealer name has to match. So you're gonna go and say dealer name column, and you're gonna see all the dealers. So in our case, we'll apply where dealer name equals or like, there is a like symbol for pattern matching. As I said, there are a lot of variations for the searches. Okay, so dealer name like GER or German, whatever, because I don't know what user is typing. You are trying to simulate the same thing, right? If I type in GER on the browser, then I should see anybody matching with the GER anywhere in the name. So you need to simulate the similar query in the backend. For that, you can use like command. There are different variations that I said. But this is a simple, right? Price, okay, filter based on the price. It is example.
It's like a math problem, like this one.
Yeah, I mean, math problem, or yeah, I mean, it's a command, right? So you need to know how to use these commands. Okay. All right. So here we are dealing with a single table. Okay. Right now it's a single table. But we know reality is if I find a tables, if I'm pulling information from 5 different tables, because when you are looking for dealer user, right? User for dealer, it will pull up from maybe 2 or 3 tables. So in your query, needs to go against 2 or 3 different tables and pull the information and show you on the screen. Now, how do you do that, right? Because this is a simple command, works with one table only. When you are talking about multiple tables, you have to master the joins. So how do I join these tables logically? You are not doing anything in the database, okay? You are writing the queries that can join these tables in the memory when you are executing your queries, and it's pulling you the fields from those different tables. Okay, so that's where the join command comes in the picture. So here, let's take a look at the example. Select textbooks. So we have 2 tables. One table is called textbooks. Second one is course tags. Okay, so I have 2 tables, table 1 and table 2. So my query is saying textbooks.title. So what is giving instruction in the query is select title from the textbooks table, dot title. So there is a command. So there is a syntax you have to follow. Textbooks.title, price required from textbooks. Then you are writing joining this table, inner join course tags. So there is a special syntax that you need to follow. Inner join course tags on textbooks.title equals course. So let me show you what it is, right? So this is a textbooks. And we know there are 2 tables, course tags. So based on the join condition, here is what I can do. So there is a title. And there is a title here. So I can, since both has a title, it has the same value, so I can join these two tables, kind of like a foreign key, primary key type of thing. This one could be a primary key and this is a foreign key in this table. So I can join that. Inner join this one on course book, textbooks or title equals where the matching condition is, right? That's what you are specifying here. Because I know they both exist in two different tables, I can join on them. Okay, now then you are applying filter condition on top of it, where categories is computers. Okay, so this is again, as I said, things do get complex, and when you are joining more tables and more conditions and those things. Okay, so
first
here,
join.
this example here, right? So I explain you the query. Now you look at this example. So you have title and title, right, in both tables. So this one has title, this one has title. And both, since both has same information, I can use it in the join condition. Okay. So this is the join condition. This is how you can join it on the common columns, foreign key, primary key type of columns. Okay, where column exists in both tables, I can join it. And on top of that, so once I let's execute, I'll pretend this is not there.
Yeah.
So what it will do? So what it will do is it will have a less logically, right? So if I join it logically here, so it will have only top condition. Okay, this up to this part. So I will have a title, course, and required a yes or no, right? Let's forget this column is not there. Okay. So this is coming from the course text. So Java intro will have a Java intro, right? Advanced C will have advanced C. Now, when you supply these two, this condition, what it's saying is match it on these two, right? So that means the title has to exist in both tables. So this calculus and philosophy does not exist in both tables.
Yeah.
Right? So it will eliminate this row. Okay, first of all, it will eliminate those rows. As soon as you execute first 4 lines in the SQL. Okay, so I will have only these 2 records where the matching column, matching titles are there. Then on top of that, I'm applying, now I go back to this one and apply the filter. So where category equals computer. So now I have these 2 records. So it will look at the category, okay, computers there, this one is computers. Then it will return both records. Now, if I have something else here, let's say I have math here. Then I will see only one record being returned. Okay, so that's how logically SQL works. You join it, filter out what's there common. Now there are variations in the inner join, joins as well. There is a left join, right join, full outer join, various different combinations. But this is the most common. 90% of the time or 95% you will use inner join, which says match it where the where you have common condition or both exist in both tables. The values exist in both tables. Okay, that's what the inner join says. So it will filter out this one and calculus is gone. Sorry, philosophy and calculus is gone, and then apply filter condition on the remaining result. Okay, so that's how you can join the tables.
So it's always written inner join or on because it's
No, that's a syntax. Inner join, what table you want to join on.
yeah. So you have to write inner join or only on. Because
No, inner join, you start with the inner join. So this is the syntax. If I am writing,
because the text here is-
I'm gonna flip here, right? Okay, so select title. What is it? Textbooks. Title, and then I'm selecting price. Let's say I'm selecting price from the course text, right?
Yeah.
Okay, from textbooks, right? Because my first condition from is what table I'm joining, first of all. Now I'm creating a join condition with the course text. Yes, so there is a syntax here, inner join course text, inner join what table, right? You start with that course text, then you say on what are the common fields between those two tables. Textbooks, what are you matching on, right? Textbooks dot title is equal course text title. This is my join condition so that I can join it on that particular table. Then if you have any filtering condition, you can say, okay, filter textbooks dot title or category is equal computers. Okay, so this is my join condition. Now, if I am joining on multiple tables, let's say I have a different table, I can say inner join, keep on adding. If I have 10 tables, I'll add 10 different join conditions. So it is like an n-1 conditions, right? Because you have one table and you are joining with 3 different tables, so you will have 2 conditions. Inner join
So
XYZ on course text dot required is equal ABC XYZ dot required. I'm just putting hypothetical here. Okay, there is some other table you are joining course text on, and let's say you are pulling that required from the 3rd table, so I can pull additional fields from the 3rd table. This is how you can build a join condition. Okay. All right. So let's
You have to write one by one.
yes, you have to follow the syntax. As I said, I mean, it's a syntax can get little bit ugly, but it's just for your purpose, you guys are good. Okay, unless you are testing the reports where you need to use little bit more SQL statements. Most of the time you have to create simple statements like select star, apply some basic where conditions and so forth. Okay, as I said, W3 schools is the best thing to learn additional things, right? I think we have free videos if you want to understand certain things further. If you go to our YouTube channel, we have past SQL sessions as well. Okay, so you can go through that, because as I said, we have full boot camp on this thing, but you can follow the previous boot camps, some of the sessions. Just go on our site, Intellect Software YouTube channel, and you will find more. And you can learn it on your own as well. Okay. I think this is one of the good skills that you can acquire from there. Okay, so let me talk about the actual database. Okay, so let me see what we have. All right, so let me just show you in the Azure Data Studio first, and I'll let you to work through as well a little bit later. I think all of you have installed this one. Okay.
My laptop is not compatible with it.
Okay, yeah, that's fine. That's fine. Let me show you. Let's pay attention here, and you guys can work through a little bit later. Okay. So once you get in the studio, right? Now, one thing you don't have is a database. You don't have rFlown database on your machine. So before you go, I want to make sure you install it on your machine so that you can practice from home. Okay. And I'm recording this so you can follow through, but let me just show you quickly. And we can come back on Thursday as well and spend another hour on Thursday. Okay, on this thing. But let me just show you. So first of all, this tool is a brand new tool. I think they came up with this tool maybe like 2 years ago. There was a different tool that was available. Okay, but this is fairly new. But for you guys, it doesn't make difference because you are brand new as well. So for you, it doesn't really matter. But what it does is you need to have a database, first of all, rFlown on your machine, which I'll help you create. Okay. The second thing is, as soon as you come in the tool, you need to say, what is my database? so that I can write the queries, because you want to write the queries, right? So first thing I need to do is create connection. And here I need to specify what is my connection string. So server. Now, all of you should type in this localhost SQL Express. This is, don't worry, I'll let you guys work through last 10 minutes or 15 minutes and we'll work through configuring here. Let me just show you quickly. Okay, so as soon as I do that, hopefully it will connect. Okay. All right, so I'm getting this error, so let me see what it is. Services. I may not have services running. Let me just make sure. No, it is running. All right, so I'll come back and see what's wrong with it. Let me see if the local host works. Yeah, it should have found it by now. Okay, so I had a typo probably. Okay, so I'm here, so I can find my database. I have rflow and those things. So I'll help you install whatever is there today so that you can continue practicing from home. Okay, but once you have it, there are a couple of things that you have to right. Where do I create my queries, right? So here I can see if I double click on it, I will see all my tables. Important part is my lender table, dealers table. Can you guys see it?
Yeah.
It's a little bit lighter.
Yeah.
There's a credit application table. Now remember the diagram that you have in the design, you have lenders, you have dealers, the relationship diagram. Refer to that, how those tables are related. Okay. And you can create simple query thing right from here. Okay, so I can just say simple query, right? Okay, so it opens this window and you can work through writing your queries. Now, simple query I can write is select star from dealers, because dealers is my table name. So I can run from my table for my table. And the good thing about tool is it will show you, well, based on your database selected, it will show you all the tables belongs to that database. So it will automatically pop up dealers. So I'll just select dealers table. And how do you run your query? Click on run.
So you don't have to select or highlight that.
No, you don't have to highlight. You don't have to highlight. Now, if you don't highlight, right? Let's say I have multiple queries here. Select star from users and so forth. Then when I run it, it will run both.
It will run both.
Both the queries. Okay. So first result, I'm going to see that, and second, the bottom one, I will see all the users. Now, if you just want to run particular query, let's say I want to run users, and I select users, that command and run it, then I'll see users. So that's just straightforward. Now, as I said, right, let me just show you. If I want just a username, password, and user type, right? So I'm selecting 3 columns separated by comma, right? And I can select that and run it. So I will have 3 different values, 3 different columns, right? Does it make sense? Right? What I showed you, I mean, in the PowerPoint, I think that's the same thing you are following here. So you can put it here or put it something like this, which is perfectly fine. SQL, it doesn't matter. I can run this query and you have to select 2 lines. You can format it nicely. Now let's talk about if I want to filter something, right? Apply condition. So that's where I apply where clause in the next line or same line, doesn't matter. But if I want to find only specific user record or find where all the dealer users. Let's say I want to filter on user type where dealer is equal all the dealer user. So how would I write my condition?
Where,
User type is equal dealer,
or dealer.
right? Because I want to find what is my type. So you need to look at the data and it says dealer or ref or whatever. Okay, so I can run it and I can get all my dealer users. Now again, I don't know where it belongs, right? So I can put the shop ID in my query and run this query so that I know what shop they belongs to.
Oh,
Okay.
So, so what do you do after you get this information out of the populator?
Yeah, this is the information you can, these are your queries, right? So you can,
This one, okay, it's assigned to.
so if you are a QA and if you are trying to find dealer users, right? For your testing purpose, because you need to know what users are exist for the dealer, right? If the dealer module is not there, then you can run in the backend because system not going to be built overnight. It will build over 6 months or 1 year time frame. You may not have all the graphical user functionality available.
So this is basically on what's on the back.
Yeah, because you will always have database. So that you will always have certain functionality in the backend that you can work through. Plus, if you have to create more dealer accounts or user accounts, you can write insert query or update query as well. Create the data in the backend. Okay, so that's where it's used. Now, how do I know which shop they belong to? If I want to pull the shop name, actually dealer name, how do I do it? So now I have to pull in the same query, I need to pull information from the users table as well as dealer table, right? 2 different tables. Because this query does not give me what shop. I can't see the name of the shop. Right now, all I can do is I can write a different query, select star from dealers, where shop ID is equal to. If I do that, then I know, okay. I made a mistake, so typo. Okay, so auto body shop. But in the same query, I want to pull the same information, right? Because if there are many dealers, I don't know what they are. So I can pull the shop name here. I want to run it like this. If I run it right now, it will throw me an error, invalid column name. Because it doesn't know where this column, which table and so forth. So that's where my join comes in the picture. So now I can join it, inner join dealers on dealers dot what's common between the users and dealers. What is common column? Shop ID, right? Based on the diagram, it shows shop ID, right? Shop ID equals users dot shop ID. Okay, so now I can join this table. Now here you see the red line. Because users table also has a shop ID, right? Column. And those shop ID exist in both users and dealers. Okay. Now here, if I run this query, I might get an error. Okay. It says ambiguous column name shop ID. Why? Because query gets confused. Because shop ID exists in both tables, it doesn't know which one to pick. So that's where you need to say users.shop ID or dealers.shop ID. Remember, we saw this command, right? Which table I'm picking that field if it exists in both tables. So now if I run this query, oh, I'm getting, okay, now I know, okay, this is German Toyota has 3 users, Auto Body Shop has 1, this one has 1 user. Right? So this is how you can build your queries slowly. Okay. Any questions so far?
Can you go one by one or we can go all?
One by one meaning?
I mean that select that type begin like row 1 line or.
No, you need to have at least a basic syntax, right? So what's minimum is select star from what table? So this is your bare minimum. Without that, if I put select star, and if I run this command, it will throw me an error. It said, I don't understand. This is your bare minimum syntax. Select star from what table. Then you start slowly build on it. Okay, I need only these two fields. So I'm going to replace star for this fields from users. And then I add my where condition and so forth. And then you come back and say, oh, I need a shop name as well. So you build on the query, modify the query. Okay, again, this is a little bit programming as well. This require practice. Practice some basic commands. Okay, select is the most important for you. If you are creating test data, there is an insert command is another important one. Okay, and the delete is important as well. Update, you may not be doing that so often. Okay. But let me just show you quickly the insert command. So right now, let me see here, select star from notes. So I'm going to pull, there is a note table. Okay. I'll just show you quickly insert statements in syntax. Okay. So there is a dealer, shop sequence number, ID, and there are a bunch of notes here, right? So if I'm populating this, some test data in this table, so I can write insert command. So there is a command called insert into what table you are populating the record into. So I'll say note, then what columns that you are inserting the values into, and then what values you are inserting into. Okay. Again, if you want to learn this command, I would suggest I'll send you the video. You can follow through in the video. There are plenty of videos online as well. Just Google it, right? What is the insert and how do I insert certain things? Okay. And if you go to W3 schools here, you go to the SQL section here, learn SQL. Again, SQL is SQL. Once you learn it, you can apply on any database. Oracle, SQL Server, doesn't matter. They all are built on standard SQL syntax. Okay. So if I come here, select SQL in select, and I can see what is the syntax, right? Again, it's a very basic syntax. Select star from table name, that is very basic syntax. They have table here, and they will show you the example here. Try it yourself. Okay, so you come here, and if you run this SQL based on the table they provided, then you will get this result. Okay, if you apply the filter condition, where city is equal Berlin, and if I run this, I should see only Berlin. So I think this would be a lot more logical for you to work through, right? So that's the reason I can give you the Rflow database. You can practice on that, but these are additional things. You don't worry about what's there. They give you the table right here. Run some basic commands, right? Same thing, insert, right? Let me show you the insert into, right?
So insert command is for creating something.
For creating new records, right? Okay. Right. So this is the what. So when you click on save, right, on the Rflow dealer page, this is what it gets triggered. Insert into what columns and what values and so forth. Okay. So right now they have a demo database with this customer ID, customer name, contact name, blah, blah, blah. And see if they have example. This is the thing you have. This is a syntax. So insert into customers. This is a table name. Now what columns you need to insert data into? These are the columns. Looks like the customer ID is automatically assigned. So you will never insert directly as part of your SQL. Okay, that's why they do not have customer ID column here. Now, so you have customer table, then you have list out all the column. Then you list out add the values command and list out matching values. So one customer name will get cardinal value, contact name will get Tom Behead, same sequence. Okay, otherwise it will mess up your you might get an error too sometimes. Okay. So if I come here, let me put my name here. Okay, and see if I insert it, I should see one record inserted. It does not show me the result. You have made changes to the database, rows affected 1. This gets you result. Okay, but it does not show you here. I think what is inserted. But here, let me see if I go to the, since we inserted in the customers table. So let me go to the customer record, and I should see where what is it? Customer name is equal Herschel P. This is a syntax in the quote, single quotes. Okay, I should find my record there. Okay, didn't put in. All right, let's run this command again. See what it did. See if I can find then. Maybe it lists out all the way then. Who knows? Oh yeah, there you go. Right. So this is, I think, helpful too. Right. Basically, you don't have to worry about any software and all those things. This is all already there. But if you need Rflow, I can get you Rflow as well. Okay, so that you can run on Rflow. But it's a very straightforward syntax, right? For this one, insert, it's not much complexity there. All it says what table, what column I'm populating in what values. Okay. If I show you the delete command, is very simple. Complexity is in the where clause, where I say select command. Select is complex. It says delete from table name where condition, right? So see if these are 5 records, and if I want to delete number 5, let's see, come here. So I'm going to try it myself. So instead of customer name, I'm going to say customer ID, right? Is equal 5. So I can just say delete record from customers. So delete from customers where customer ID is equal 5. Okay, so it will delete on the matching condition. Now, if I don't specify the condition, what would happen? It will delete all, and it will wipe out the table.
Yeah.
Okay, that's why this where clause, they typically do not give you access. Okay, to run this thing. But here it says 1. If let me run it without anything, see what happens. It says 91 rows affected. I just deleted the whole database. See, it shows customer record 0.
So you need to be careful when you're using delete command.
So when you delete it, you can never like undo it.
No, you have to restore the database table. You have to restore it from the backup. Yep. Same thing with the update. If you update certain things and if you don't put the where condition, it's going to update all the records.
That's why it's a very careful.
Very careful. If you have 1,000,000 records, I don't know what you're going to do. I've seen people getting fired, okay, on that one. So, but you will never get access in production. They will give you access to the 1 or 2 people who is managing the database. Only they will have access to do certain.
That's good for us.
Yeah, but test data, you can delete the whole thing, and what you gonna do? If you don't know what command you are running. Okay, so it looks like I just deleted the whole customer table. So, well, hopefully they'll populate here, or some of you will populate back. Anyway, so that's a good part. Let's see here. So I showed you some of the command. I think so. Practice, right? This one requires more practice. Okay, SQL. More time you spend on it, more commands, and so forth. So where command is important, I think you already know it. Again, there are variations there. So just spend some time on SQL. Okay, I think this is a good site. I wouldn't worry about Rflow, setting it up on your machine. Go here and work through that.
So what about
What?
So I have a question for the homework. So could we just go ahead and do the homework on here?
Yeah, just on this side. Homework is more practice. Where clause, whatever command I showed you, right? Insert, use the insert one because you need it for populating the data tables.
I'm talking about the HTML and the.
Or you have to do that, okay?
Your machine, you have to-
I think if you do the XML and JSON today, that would be great, because we're gonna use it tomorrow. You need JSON and XML. Create a document in JSON, XML format, just review that and get it done today. SQL and HTML, you can do it for Thursday. Okay, SQL HTML for Thursday, but XML file, create brand new and see if you get familiar with the syntax. It will be helpful for you for tomorrow's session.
So SQL and HTML.
SQL for the Thursday, JSON file and XML, right, for tomorrow. So create one that places whatever in JSON and XML. I don't think it will take you more than 30 minutes. Shouldn't, if you follow the structure in there. Maybe 1 hour, worst case scenario.
Before doing it for practice, then go for it.
No, you review what we taught, right?
Yeah.
Review,
Part of practice.
Practice.
When you write it, that's when you're gonna get the practice.
right?
So don't think it that you have to practice first and then write it.
No.
Just take that, try to create it, figure out what's going wrong, look at it and practice it right there.
Right.
Oh,
Unfortunately, technology side, more practice you do, I mean, that's where it's gonna get you. Okay, because now other stuff is there, it's already you understood the core
You
part.
understood the process.
Yeah.
You have to just apply it.
All right, so I think everybody will work through this W3 schools, and I should see at least 100+ records in the database now, hopefully by Thursday. And
We'll
you
do
guys,
all the work that person has done.
Yeah.
So.
that's right. Yeah, I just wiped out that customer table, so hopefully,
that's what-
I'll see.
That's why it's there. It'll be
Yeah.
restored.
Oh, I know, I'm sure they will restore it.
No, it becomes a reset as soon as you left and come back. As soon as
Yep.
the session gets over.
Yep,
So what will be the password? It's not predictive. This Intel.
for password for what?
The
All capital intervals.
So we are not doing the Afron, we're doing practice.
Yes, you will do it. I think that's easier. You can follow, read the instruction and follow through. That would be a lot better. Yep. If you need it Rflow, I can hook you up. Once you practice here, I can give you Rflow on Thursday.
Maybe we can do it tomorrow when we leave. We can get.
No, Thursday. Let's focus because tomorrow we're gonna cover different things. Tomorrow it's a lot more hands-on as well, so you will be working through different things. So everybody good online? Everybody guys understood what you guys need to do? You won't install, don't worry, because you're gonna practice here, right, on W3 school. Yeah. Everybody's quiet online, so I'm not sure they are there or not.
Yes, I think we are good. We will practice on W3 school.
Yeah, we're good.
So Seva, the homework is XML and JSON exercises. And I'm gonna send it out in the email as well.
Okay.
Yeah, that would be grateful, sir.
Anything else? Any other question? You have a question? Yeah, go ahead.
So last Thursday you told you can invite, this is not for today.
Oh, okay, the project, okay. Yeah, I think I saw one email from somebody. One of you guys sent me.
Can you explain one more time how to invite you?
If you go to the dashboard, you will see invite user button. You just click on it and type in the email. So if you are working together, 3 people, you can invite 3 folks and 4th would be me. Don't invite more than 4 people. Yeah, I'll watch you guys. Yeah, I'll watch you guys, see what you guys up to. But that's the way, right? And only one person from the team can invite so that I can see,
Yeah. so-
not everybody, okay? Because otherwise other teams cannot add.
So this process comes after the software development lifecycle.
This process is while you are building the software testing. So when you are executing your test cases, that's where this comes in the picture, SQL.
So that comes to the test.
Yes, testing phase. Yep. because you are verifying what's in the database. If I click on save, I get a success message. But then I search on it, I don't see anything. Right? But at the same time, you can go in the database and see why something is not there. It might be just that they have button, but doesn't do anything.
DevOps and
You execute the test, run it, right? Follow your instruction one by one, and verification step. You are verifying something in the database at that point. Because if you say this one's supposed to be saved in the database, right? But I don't see anything in the database. That means it just refreshes and says, oh, everything is good.
That means you can see on the front end, on the back end.
Back end as well. Yep. And you trust me, you will end up doing back end as well all the time. Yeah. All right, so today was a busy day, right? 4 different things. Spend some time, right? Because we're gonna dive into new things and new topics as well. No session next Saturday, right? You guys all know it. So I don't need to repeat. Only Sunday next week. I just want to remind you guys.
25th.
25th we do have it, not 24th.
Next, we have the second and third and then eighth.
Yep, second, third, and 8th. Yep.
We execute only tomorrow only.
Azure? I'm not sure.
Data Studio only tomorrow.
No, we don't. That's something if you want to, we'll install Parflon on that and you can practice on that for Parflon. All right, then we are wrapping up then. Everybody good?
Yeah.
Online folks?
Yep, thank you.
All
All
right.
good.
Okay.
Thank you. Yes, we're good.
And make sure you guys show up on time, okay? Who are, okay, most of the people are, so. All right, tomorrow, otherwise. you're gonna
Okay.
miss it. Yep, okay, all right,
Thank you, sir. Have a nice day.
Thank you.
bye-bye.
All right, thanks.
All right.